Here we are. Where's the camera today? Over here. Hi everybody. I have a different camera location today, and anyway, welcome everyone to the Keshe Plasma Reactor group for Tuesday, October 11th, 2016. And once again, here we are with who knows what and who knows where we're going to go with it. But nevertheless, we seem to get through 3 to 4 hours of this program every week, and it's hard to shut it down at the end for some reason. We could probably go for days once we get rolling. Anyway, I've got some stuff lined up here. You can see my test tube rack that I actually got at the craft store. They have them on sale for Halloween. So it's cheap, but it works. Don't trust the test tubes though. They're not designed for high heat. They're designed for decoration. However, they'll work in my case. Yeah, and I've got this arrangement here that we're going to have a go at, which is, whoops, my camera's not holding. There we go. And I've got a basic crystal radio setup that I had last week. I've got the coil set up here. I've hooked a couple of wires into the coil attached by a coil type attachment, like in the way Armin does it originally. And inside the coil here, I've got this very special pain pad that I was given last week at the Vancouver Island Plasma Workshop with a bunch of ladies that put it on up there. And where the workshop was right across from a Buddhist temple. And they apparently had a gold Buddha there and so on. And one of the lamas gave away his bedding apparently, and somewhere, or sold it or something. Somebody picked it up in a thrift shop, and this is genuine llama bedding that's been made into a pain pad. So I thought that's pretty cool. So I rolled this up and tucked it into the coil here, and that works really good. So then I can use that as a way to insert these test tubes for certain testing and different arrangements. So we'll get into that in a little bit. That's one thing. And I've got a couple of test tube sensors here. This one here in particular will be interesting to try. And it's got there's a triple coil arrangement inside, and it's all wired into a audio phono plug here, and stereo. So you have two channels from the outer coils, and the ground will be the center rod. So we'll see how that works. And I'm going to hook that up through a normal audio cable into something I picked up this week, which is really great. It's really cool. It's called an iRig, and it's iRig HD actually, and it's got I think it's 24-bit audio. It's nice quality audio. Plugs into my computer here, and plugs into the system here through the other end. So it's a little preamplifier. And it also it's able to take the signal and put it into the computer properly, which some units don't. So it's even got an adjustable preamp on the side here, so you can give it more or less. It's designed for a guitar, so you normally would plug your guitar into that. Can you see it there? It's not very good lighting. There. Normally you plug your guitar in with a 1/4-inch phono plug, and so that goes in. I have an adapter down to the 1/8 plug, so that just goes right in there. And so what we're going to do is get this thing going through the audio hijack program and see if we can get some sound out of it. And I've also got a test tube of plain distilled water here, which I'm going to use as a standardization for the coil, see what it sounds like with the distilled water. Then I'm going to try this is salt water, and it's pretty much saturated salt water. We'll put that in and see if that makes any difference in the sound. I haven't tried this yet. I have no idea what it's going to do. Then I've got some Gans material here. This is very special Gans material. It was brought to me by the this is very special. It was brought to me by the ladies that were running the workshop, and they had collected this from oceans, like from the east coast, west coast of North America, and it's ocean Gans that's been created by putting caustic into ocean water, essentially, and it's several different kinds it's been created several different ocean waters. And so we'll put that in and see what that sounds like, see if there's any difference in the tuning of the circuit by putting these different materials in. And also what we'll be doing here, I'm going to take I've got these little balls, ping pong balls that I've put together. There's 3 of them, actually 4 altogether, but they're color coded. So we've got the CO2 Gans water in this one. It's filled all the way up. There's no air bubbles in there. And then there's the CH3 Gans would be in this one, Gans water, that is. And the copper oxide is in this one. Hello? Someone trying to... Getting a little bit of feedback here.
Oh, was that me? Sorry about that. I'm trying to set up a spectrum analyzer and an oscilloscope so I can monitor your audio that's coming through.
Oh yeah, cool. Yeah, that'll be another part of it, because it turns out this iRig device here is this really cool little preamp that really makes the whole radio thing work well. Besides hooking up to a computer through its cord here, it's also got a cord that you can plug in that plugs into a normal iPhone. So you can actually run this into the iPhone and have an input from the iRig into the iPhone. And you can run different apps in the iPhone to amplify and work with the sound. Or I can run an audio cable from the iPhone directly to my computer, which is more likely what I'll do, and use the computer power there to alter the signal. But that's pretty cool, and I'm looking forward to doing a lot more work with it since it works so much better. I was actually able, yesterday I was able to tune in the circuit so I could hear a radio station through it. So I thought that was pretty good without even a full antenna on it. So anyway, I think I'll just sort of whet people's appetite for that for a bit, and I'd like to get in to see what Lee Coates has here first. Let me get your video up there, Lee, because you got something cool you're working on as usual, and we'll put mine on reserve here for a bit. So what's happening there, Lee? What do you got going?
Okay, yeah, I still got your picture on the screen here, so.
Oh, there, maybe that'll work. Good.
I've been making these car magravs, and basically I'm doing a bunch of testing, so I got my little baby magrav, car magrav with the 18 gauge and the 16 gauge one. And I had the double magrav that I was made for some other purpose, so I rewired it for as a car magrav just to test the triple coil, just to see if I got any more strength out of it, and that just got wired up yesterday. Yeah, so
you
I
have
think
a triple coil wired up like a car magrav, which is usually has separate coils with each wire goes to each coil. So how do you wire up 3 coils? You must tell us how you
well,
wired
the
it.
coils are just in series. Like I got
Okay.
like in the car magrav, you got one coil on the bottom, one coil on the top.
All
On
right.
this one, it's wired with 3 coils on the bottom, 3 coils on the top.
Oh,
So
okay.
I'm just
So
seeing
you
if 3 coils makes a difference.
you still end up with one wire coming out of the top 3 coils and one wire coming out of the bottom 3 coils. Is that the way it
Exactly.
works? Okay.
So it was just since I had it all built already, I figured I'd test it out. So
Well, why not? It's
that was
you,
that one.
and
But those are those other 2 or 3.
well, you're getting quite a collection here. It's just you're prolific with these little guys coming out.
Yeah, I gotta show my spreadsheet here. Okay, so I got 10 units built so far. The first ones it was in my truck back on September 25th, and I've gone through 2 tanks of gas, and I'm not getting any results on it. Basically, I'm in the highway sort of gas mileage for highway travel. 16 miles a gallon for my truck. Uh, and I connected it to the frame and to the positive on the battery. So then I put the second unit in my dad's Dodge minivan, and my mom and dad just moved back to Manitoba. So on the trip, he was pulling a trailer with this Dodge minivan, and he got it into the sort of the high mileage range that he would normally expect on the highway or without a trailer. So he was kind of happy with the results, but nothing too impressive there. And again, I connected his to the frame of his car. I gave one to my sister Robin. She hasn't got it in her car yet. And then my niece Tammy, I put it in her. She's got a Dodge minivan. Put it in her van for the trip back to Manitoba. And when she got back, she said she saved $60 on her gas bill going back. So she was really happy on that. Now hers, I connected to the battery, to the positive and negative terminals on the battery. So thinking that's the way to go. These other units, I've been these first ones, they just had hot glue putting the coils together. This number 4, it had lots of hot glue. I tried to get it in the coils and really glue the coils together. The first 3 did not so much. The number 5, I put epoxy glue in it. And number 6, I put epoxy in it. And they're still sitting here. I got put extra. The first ones I got. My theory is that the strength of the plasma should nanocoat so many feet of wire per day. Okay, so if I get a combination here that's stronger, I should be nanocoating the wire faster. So that's sort of my gauge for how strong the plasma field is on these things. That's my theory anyway. So that's what I'm trying to test.
Well, that's a good theory or a good thing to be testing. Actually, yeah. That
So
makes sense. Judging the strength by how fast it moves down the wire.
yeah. So So on my truck one, I had only 5 feet of wire, and then it took 3 days to nanocoat, so it was say 1.7 feet per day. my dad's van, it had 8 feet of wire and it took 5 days. So it's again 1.6, 1.7. This is a real coarse test because you got to judge. It's a judgment call on how black the wire is. Okay, and then plus you're not looking at it every hour to see. So it's really
So
coarse.
are you looking for blackness, like black, or just some change in color? Like how do you judge that yourself?
I'm looking for. These were the first two here were black. Okay.
Mm-hmm.
It's sort of a couple days ahead of time. You can sort of see it starting to turn, and then. But I'm waiting for it to be black. But
Mm-hmm.
again, it's a judgment call. How black is black?
Mm-hmm. As long as you
Number
know
set.
with each one where your limit is, then you can judge it that
Yeah.
way, I guess.
Yeah. Number 7 here. It turned black again. I had a 12 feet of wire, and it turned black again 1.7 days per or length of wire per day on that one. Now this one I put epoxy, but I put CH2 Gans in the epoxy mix. So, and these other two with the epoxy had no Gans mixed with the epoxy, and I'm still waiting for them to turn black. So there's, I'm sort of thinking I need to put epoxy with or a Gans mix in with the epoxy, dry Gans, and then these other three that the number 10 there is that the big triple coil magrav. It's just because I had it, I did it. And these other two, I used. These other two, I did something different. I put lead Gans on the gravitational coil. Like these first batch, I had CO2 Gans on the gravitational coil and CH3 Gans on the magnetical coil. And I said, well, let's get do something different here on these number 8 and 9. I put lead Gans on the gravitational and CH3 on the magnetical, and then on actually I didn't use epoxy. I used the fiberglass resin from Canadian Tire. It's a little bit cheaper than epoxy. So I put CH3 powder or dry Gans on the gravitational and CH3 dried Gans in the resin for the magnetical coil. So, and they've just and then I've got a real short wires on these, because what I'm going to do is I'm going to test different lengths of wire in between the short wires, just to see how quickly. Like I'm thinking, say a 2-foot wire is going to nanocoat quicker than a 12-foot wire. So I just want to sort of go 2, 4, 6, 8 just to see how quickly the wires nanocoat on different lengths of wire, because I suspect the longer the wire, the longer it's going to take. So I think that's another variable. So anyway, I can show you some pictures.
Nice method, Lee. I like that.
See if I can find my picture screen here. Okay,
Okay, Rick, is this? Are you still getting the feedback from me?
In the background, but it seems okay.
Okay, so I got the buses correct. I can do a spectral analysis in the oscilloscope now.
Oh, cool.
So that's number 5. That's just straight epoxy in it. Number 6, straight epoxy again. This was mixing some CH3 Gans in the epoxy for number 7 here. So that's the number 7 with the Gans epoxy in it. That's the one best performer so far. This is mounted in the car. I had to drill a couple holes in the frame at the front here. It's the only place I could find to mount this, and then I tie wrapped it on there onto the frame. So that's on the frame and attached to the wires to the battery. It's sort of over the exhaust here, but it's getting lots of airflow, so I'm not too worried about it melting or anything. That's in my truck where I attached it to the frame, and that's wasn't working too good. I've changed that to the battery now. That's my truck with it attached close to the battery. You know, I took it off the frame, and now I've got it on the negative terminal. We'll see what change that makes. So now we're back to some of the original ones. Anyway, that's the update on what I'm doing with my car magravs. So,
Yeah, yeah, really cool, really cool. Boy, you got a lot of units you've put together there. That's over what, the last 6 months or something, or when would that be?
it's last
Last year?
last month actually.
Wow.
So yeah, they did the car magrav. It takes about 4 hours to make. You know,
Yeah.
not counting the time it's in the nanocoating bucket and stuff like that. It's just 4
Mhm.
hours labor, twisting coils and making frames and doing connections and stuff.
And that's
So
when, after you've gotten the hang of it, basically, too, eh?
that's right. After you've made
The
10, that's how long it
first
takes.
time always takes so long.
Yeah. So yeah. So I'm sort of thinking if I get some good results here, which I've got a couple of good results, or I got one good result and a couple of, and I'll put some. I want to put them in a couple more cars and friends, and I can get some more test results, and maybe I'll get a little cottage industry going here in Okotoks, making car magravs or something. Get myself a little revenue.
Yes. Well, that'd be interesting. You
So anyway,
get some good testimonials and whatnot. It'd be nice to have a really objective way with the fuel mileage to. They do have apps for iPhones and so on. You can plug a little sender into your what do you call it? It's the connector that's under the dash for the computer, basically, and it broadcasts to your iPhone, and you can actually look at your mileage and everything instantly through the iPhone that way.
okay, that's interesting. I know my dad's car's got the little gauge that tells him how many miles per gallon he's getting.
Oh yeah, yeah. I guess some of the vehicles have that. So.
You should try and get friendly with a trucker, and I know they got all kinds of computers giving them mileage. Put one on a big rig or something. See
Mm-hmm.
what happens.
Mm-hmm. That would be definitely
But
interesting.
I'm a construction guy, so there's I'm if these things promising, I'm gonna go see one of the excavators, and they got lots of trucks and backhoes and all kinds of stuff that could use something like this. So
Mm-hmm.
we'll put a couple of units on some of their rigs and see what happens. So
Yeah, yeah. I was just reading about that industry, and they're a little jilted a bit because they've had a lot of promises for different devices that are supposed to save them money and so on. And of course, most of them don't really, but there are some that do, and it would be great to. They do government tests on that kind of thing as well to confirm if they actually do, save 20% or whatever they say on the bottle or the device, depending. And that would be so cool if we could get into a government program that actually tested, objectively tested that kind of thing.
yeah, well, for starters, I figured I'd just go to the boss and say, hey, I'll put this in your truck for 60 days and come back and see you then and see if you want to buy it or you want me to take it out.
Yes, right. I guess
See what happens.
he keeps track of the mileage and so on, of course. That must be part of what they do.
Yeah, I'm thinking most people are going to be pretty skeptical to start with. So man, just offering them to put it in the one truck for free and see how it goes, and might be a way to get in with some of these guys, because some of these guys have got a fair amount of equipment that's got motors on it, so it'd be a good market. Anyway, that's my update on that for right now. Any comments or questions or?
Okay, anybody got comment or question for Lee? Come on, don't be shy. It's the little button that says unmute.
This is Willy.
Hello?
Willy from Norway speaking. I'm sorry. My microphone is off.
Willie from Norway. Okay, sure. Yes.
Yeah.
Hi.
I just want to say I admire your work laborly. Thank you. You inspire.
Thank you. That's what this is all about. This Rick's meeting here to inspire everybody else to get going.
Well, that's true. A lot of it. It's true. You know, it's not necessarily that we come up with the ultimate objective device that's solving the world's problems, but we do come up with ideas that provokes other people to try something different and think about it this way, think about it that way, and it's opening our minds and our abilities and so on as we try different things. And I enjoy, seeing each new device and the different angles. Every reactor, as Mr. Keshe said, there's as many different kinds of reactors as there are stars in the universe. And that, is literally true. In fact, more so, because it goes to infinity, the number of reactors, because each one that you create, like no two of the ones that you've created, Lee, are the same. Even if you try to make them identical, there's going to be little differences. No two coil sets are exactly the same, even though we try to make them the same. But sometimes the nanocoating's a little thicker here and there, or different, it sits in a different part of the tray where it's drying, and it's just a different condition there than the one beside it, and so on. There's so many variables that each one is unique in its own way.
Yeah. Just for anybody new here, this whole idea for this car magrav came out of Keshe Foundation in Peru, and they've got some videos on how they make it down there. So
okay, that's helpful. Thank you.
It's not my original idea, so just so if you're looking for more information, you can go to their website and their YouTube channel and see some videos on what they're doing.
Alrighty. Do you have anything else you want to show and tell there?
Well, I do, but I just figured I'd let someone else have a chance.
Okay. Is there anyone else that has something in particular they'd like to bring up or show at this moment in time? Otherwise, I'll have to subject you to annoying sounds from my devices here. Is that...
Sorry, it's Eva. I have a couple of questions regarding if you have nano-coated coil and then Gans coated, and then you figure out you have done something wrong, and you have put wrong Ganses on. Can you clean it up and put other Gans on after?
Well, I think that question came up before we started the meeting today. Is there a comment on that?
I was out making coffee.
I don't think there's actually a wrong Gans that you can put on the coils. If you're going for a gradient, heavy on the bottom, medium in the middle, and really light on the top, then yeah, okay, I can see how you could see that as wrong. You can just wash the Gans off. It'll come off quite easily. And
with
yeah,
just
you can
water
replace
you're
it.
talking about.
It's not going to cause a problem.
Just using water, you mean, John, right? Not alcohol.
Say that again, Rick?
Not alcohol or something, just water?
Yeah, just clean water and put it in a bowl and put the coil in there and swish it around really good, and you'll see the water will get cloudy and that your Gans is coming off. You'll never get it all off, so don't worry about it.
Okay, thank you.
Okay, that's helpful. Okay, any other questions or comments? Okay, well, I'll have to...
I've got a question. Rick.
Okay, let's chat.
I'm new to this, but anyway, I'll ask them. I hope. Lee, were all the connections that you made on the installs that you did, were they all positive and negative of the battery?
I'm not sure I understand the question.
Like you didn't connect negative to the frame, or it was all positive and negative of the battery?
The magnetical coil, it connected to the positive of the battery, and the gravitational coil, it was suggested that we could either connect it to the intake manifold, the frame of the vehicle, or the negative on the battery. And my nieces had good results connected to the negative of the battery, and I've had poor results connected to the frame. So I've switched to the negative of the battery, but I haven't had any, haven't bought gas since I've done that. So,
Chad, one of the things, this is John, tech support. I'm working with Dave down in Peru with the systems he's testing. And one of the things that we were looking at is look at the flow of the plasma. Where do you want the flow to go to? If you want it to go through your rotating devices, then make sure that your electrical path, if you view it as an electrical path, is going to go through your engine and transmission. If you connect it to the frame, then your plasma path is going to be mostly through the body of the car. Dave down in Peru, he puts them on the battery. That's how I did Carrie Ellis's van, and that gives you really good results right off the bat. But we're asking people to test different things. Put a ground on the back of your transmission. Put a ground on the rear end of your car. Try different places and report back and see how that pathway changes the results.
Okay, thank you. And I have one that's very helpful. And one last question, Lee. Are there any significant variations that you consider significant in the way you built each unit? Is there any? Is each one identical?
no, they're all. Well, there's a couple of them that are identical, but they're all a bit different. How do they do them? Like some of them, that's the basic unit, is just a couple of end caps for PVC end caps, pressure caps with the coils in. I'm also testing them with a PVC pipe frame around it, with inside of the pipe frame nano coated, and then inside of the pipe frame is stuffed with plastic bits, plastic shavings, and then I put caustic in there to nano coat it, and then I dump the caustic out, and then I fill it with CH3, and I'm trying to get more of a field around the caps inside in the magrav coils. So that's a separate test. So I'm testing some with the Gans frame around, and then without the Gans frame around, trying to see if I'm going to notice any strength difference. The first ones I didn't. One of the things on these car magrevs is you got to not have any vibration or the vibration of the car. You don't want your coils vibrating because you'll wear off the nano coating. So that's first two. I just had some hot glue in there, and then the fourth one I had lots of hot glue in there, trying to squirt it in between the coils to the inner gravitational coil on the coils. And then I went to epoxy and basically fiberglass resin. And the number 7, the one with the glass resin with the CH3 dried Gans mixed with it, it looks promising. So that's still in the testing phase. It hasn't got into a car yet. So so I'm sort of pursuing that putting the the Gans and the resin.
And as I understand it, Lee, the coils are all standard to David and Peru. Is that right?
Yeah, the coils are just standard magrav coils with the 144 turn on the big coil and the 81 turns on the small coil inside. And but I'm testing different wire sizes too. So I've made one with 18 gauge. I got one with, well, several with 16 gauge. So that the 16 gauge fits in the 3-inch end cap pretty nice. The 18 gauge will fit into a 2-inch end cap, and the 14 gauge you need to go to a 4-inch pipe end cap. And I've got some 4-inch or some 14 gauge coils just in the nano coating bucket right now. You know, so I'm testing the different wire sizes just to see if that makes any difference too. But so,
thank you very much. Thank you. Thanks.
You're welcome.
Okay, thank you, Lee. Any other questions for Lee, or shall we let him go? For now. He's got more in the background, I think.
Well, it's not a question for Lee, but René's asked me if he can show the new magrav, which he used to produce gold. And I suggested perhaps later after we do our experiment. Did I not come through?
Which experiment?
Your noise.
oh, that experiment. Okay. Sure, well, let's get into that for now, I guess, and see how that goes. All right. Let me get my video pinned. Okay, and okay, that's working good. Okay. I just have to do one thing before I do that, which is drag a screen over that is hidden. Put that back up. And I'm gonna bring up the live stream channel just a second here. Okay, I've got the live stream hooked up there now. Okay, well, let's have a look here and see what's going to happen. I'm not sure if all our audio settings and so on are correct, but I'll try not to torment you too much if I can make sure I get them adjusted properly. Okay, just to review, zero in a bit here. Alright, that's not too bad. So, let me get a pointer. I need a pointer. So we've got, just so people sort of know the overview of what's happening here. You see there's the coils. These are the standard, what I call the standard magrav coils. Coil, an inner gravitational coil with an outer magnetical coil. There's two sets of them, and the inner coil set is the gravitational, and the outer coil set is magnetical. And so what I've got is that's one section. I'm using that as a sensor, actually, and that's tied into this crystal radio circuit here. And there's it's difficult to see probably, but maybe I can get it up there. there's a little diode right there, and that's a 1N34A diode, and it's glass. It has a marking at one end. It's a germanium oxide inside there. Again, one of the oxides. Then there's a capacitor and a resistor here, which is standard in these crystal radios across the headphone circuit. And here I have the headphone output. This will go to the iRig device that I showed earlier, this thing. And then we also have, there's this variable capacitor here. Again, that's a standard sort of thing on crystal radios. If you get a crystal radio kit, they almost always have a little variable capacitor like this, and you're able to twist it a little. And in this case, there's a coil, some finely wound wire. I bought this as a unit. It's a nice little unit. It has, it's able to move this piece in the middle up and down along the coil here, so it changes the ratio between the coil sets, you might say. And so that's all hooked in together, so it's more or less a tuned circuit, but it's kind of tuned differently than it would be for a normal radio. I wasn't tuning it for radio necessarily. So these two coils are attached by a wire coil set. Hard to see the focus there because it's, let me try focusing a little better. Right, there you can see that now. And they are partially nano-coated. I have to do a little more work on them to totally nano-coat them. I wanted the nano-coating, I wanted a plasmatic nano-coated connection here and here, and it goes back to the matter level connection in the actual circuit block here. Okay, so that's the basic lowdown, and I'm hoping to put in different Gans balls into the center here, and we'll just take a sampling and see if there's any difference between the Gans water of these different balls here.
You're going to need to refocus again, Rick.
Yeah, I see that. Thank you. Just leave it on autofocus and then take it off. That should keep it from... Okay, that's not too bad. Alrighty now, and let me do a screen share of the app of the software that we'll be using, so people sort of have an idea, because I don't think I'll be able to do both at the same time. Let me see there. Okay. So this is the software. There's a couple of different effects. We have different modules that are gain modules, a bandpass, a pitch, another pitch, a third pitch, a reverb, and an EQ, 10-band EQ modules. And I can set these up so I can see them here. Okay. And so there's the 3 pitch modules. And what I'm able to do is alter the pitch in real time of the signal that comes through, which is quite interesting, and also change the filter to the bandpass filter to alter whether I want high range or low range audio signal to go through. So all these things, the double gain and so on, are necessary because the signal is quite weak. But of course with the iRig device it has a preamp, so I won't need as much gain as I have in the past, and we'll be able to keep that down a bit, I think. I'm going to normalize some of these settings because I had them turned up before, so we'll have a baseline to start from. Okay, and okay, so I just wanted to show you what it looks like. It has input settings and various other things. I've got a couple of different setups ready to patch in, and that's ready to go. So what I'll do is I'll stop the screen share and go back to the video. I'll have that set up on my other screen.
And if I see
Actually,
any interesting artifacts in the spectrum analyzer or the oscilloscope, I'll just share screen and show everybody right away.
okay, cool, yeah. Now, let me see if I can get this set up both at once here. Maybe that'll be interesting. And 2, 3 of those. Just put them up that way. And you can sort of get them in, but oh, that's the way to do it. Okay, there we go. And what I'll do is I'll do the screen share of, no, I'll have to do the video that way. Okay, I think it's a little clunky, but I think it might work. Okay, so zoom in a bit more here. I have to be able to take in the whole picture though. Okay, I think I'm ready to go here. I'm going to make sure my rig is plugged in, which it is. And I'll just going to plug it in. This is the iRig device here. It's attached to an audio cable. The audio cable is now going to get plugged into the to our little circuitry thing here. And next I will start up the audio hijack, and we'll see what that, I'm going to turn it down to start with so it's not too overpowering. I'm not sure how it's going to go through. I might have to change a couple of the audio settings to see if I can get it to work better. Let me see, which one is this on? It's the, I want to do the other one, this one. Okay, let's see if this works. Can you guys hear that right now? A little bit in the background?
Nope.
Okay, let me I'll turn it up and I'll see if you can hear it. If not, then I'll do a different kind of audio. So you can't hear that on the Zoom, correct?
No, it's not coming through.
Okay, let me try it differently then. Because they could hear it on the live stream somehow, because it's headed on the live stream desktop audio capture. So let's try it with the built-in output. I don't think that'll work, but I'll try it anyway, see if that works. Can you hear that at all?
No.
All right.
I got a very, very low frequency showing on the scope though.
Let me try it different. Still nothing, eh?
No.
Okay. I think then I'll have to go through my speakers in order for it to show up or something here. Let me see if there's another way to do it. Output to... Try it that way.
There it is. I didn't
Right.
have speakers.
It's just coming through my speaker, but... Actually, where is it coming through? Oh, it's coming through my display. Well, that's interesting. I didn't even know it could do that. Okay, let's see if it, let's see how it's going to sound here. Okay, I guess that'll more or less sort of work. You can hear the noise in the background, correct?
Yeah, it's pretty quiet. I think Zoom is cutting it out, thinking it's noise.
Probably.
That's better.
Okay, I'm not sure if you can even hear me over the din here on live stream or on the Zoom, but let's give you a sound check there, John, or whatever.
Yeah, we can hear you. You're quiet, but you're there.
Okay. Let's see if there's one other. I think that's the only way I can do it. Let's see, just one more thing
If
here.
you put up your screen share and share computer sound, it come through just the same as your microphone does.
Screen share and share computer sound. That's an idea. Okay, thank you. I'll share the desktop, and that way you can see everything too, I think. Hope it doesn't feed back strangely, but let's try it. Can you hear that okay?
It didn't significantly change though.
Oh, that's probably because it's on display. Just a second here. different inputs and so on here. So if I go to default system output, perhaps, let's try that. Can you hear that now?
No.
Still don't hear it?
Nothing now, Rick.
Oh, okay. Boy, it's really coming through for me. Okay. So I can't do it that way. I'm going to have to do it with just... No, that wasn't it. I'm going to have to work with display audio, I think I think that's the only way it's going to work. So you can hear that, but you say it's not very loud?
Oh, it's loud. You want to kill the reverb because you're picking up reverb.
Oh, yes, right. Didn't want that, actually. Okay, well, that still should work okay that way. Okay, well, let me just try it a bit here and see if I can get it to do something. It's a little bit awkward, but... Alright, so let's see if anything makes a difference here with find my pitch. Alright, so I'm going to put in distilled water. Into the tube device here. It didn't seem to make any difference to the sound. Let's see if I tune this in a little bit. Not getting much difference there. Definitely there's a slight difference when I move my hand over to grab this. Not very much. Probably if I do this.
Seeing a very interesting spectral waveform.
Right now, or when I did that move?
Just when it's idling, it's very regular set of steps that it's picking up. I don't know whether that's artifact of fluorescent lights or if it actually comes from the device itself.
Well, it is picking up the modem signal right now because it's fairly close to the modem. And it gives that chop. It's about a 10 hertz frequency or something like that. Sounds like a woodpecker, kind of.
Yeah, it's not what I'm seeing on the spectral analyzer, though.
Okay. you're seeing a series of steps. That's actually what I'm looking for, is this like a series of octaves or something like that. Okay, I'm not going to put this. Okay, you've got the screen share. Let's have a look at that. And here's the difference with the distilled water, if any. Don't see much difference there. Let me try the salt water. I'm going to do a bit of fine tuning here.
There's a definite bias at 300 hertz.
300. See, I can. I do have the ability to alter the band pass, so I can make it lower. Or I can make it higher. I can also narrow the band. So, okay, so is that peak at, what's that peak at, that lower one? There, yeah. It's probably 60 cycle.
300.
300.
First bar 100, 300. What's that? 600, 800, 1,000. Yeah, it's not a logarithmic scale. It's a linear scale.
Interesting.
But the
Okay.
thing I noticed on the lower end of the spectrum, you have a regular peaks in the frequency. They don't seem to shift around. Their amplitude changes, but the frequency, it's not a harmonic, but it's like, 10, 12, 16.
Definitely amplifies the signal somewhat to put the test tube in. Now let me try.
You have a test tube with Gans in it. You put in it.
Yeah, that's what this one was. This one. That last one I put in was CO2 Gans from seawater.
Oh, from seawater. Oh, okay.
Turn down the.
kind of leaning towards thinking that it's going to be more like your magnet test, where a static magnet on a coil is going to do essentially nothing. It's got to be moving.
Oops. Don't touch that. Okay, well, let me try, going to try putting on just a Gans ball onto the coil set here. See what happens with that, if anything. This is all kind of finicky. It needs to be kind of tuned. I have to retune everything each time because of the how sensitive the whole system is. And plus, I'm not sure whether this is nano-coated and connected properly and so on. But we should be able to get more of a response with these. Bit of a quieting effect from that one, for sure. Okay, so let's try the Gans ball, see if that makes any difference. I know that if let me see, I guess you can't see I'll put this over here so they can see it on the live stream. There we go. And just put that there we go. Okay. Right. Okay. So here's the Gans ball. Now I know that if I put my hand on these coils, it'll alter the sound. Not as much as I expected. That means it's out of tune a bit here. I'm going to try my other setup. Let's see the other patch setup here. Let's see how that works.
Okay, now looking at that spectrograph with the quiet, I'm thinking the artifacts I was seeing before, they could be a function of the digital conversion.
Like, this is what it is with it off. So now you're hearing just the audio from the speaker. So that's the baseline, basically. Now if I was to turn it on. Now you can hear this okay in your system when I turn this on now.
If I can hear it, it'll show up on the spectrograph.
So I guess I hear it in my headphones, but you're not hearing it, right?
No.
Okay. So I have to reset it at a different setting here. Okay, input. Try that. Okay, let's see here. It's not making the difference that I wanted to get with it here. Seems like it's picking up a lot of noise. Might have to change the location a bit. It's quite sensitive to the modem noise. Well, it's not quite as sensitive as I had it last night, but it took several hours of messing around to get it to that point. Just going to try something else here, which is using the test tube as a sensor. I've got two of them to try here. Let's see what that sounds like. Not getting any sound from that.
Yeah, I got a feeling we're going to need to be a little more fussy with the conditions and perhaps stick this thing in a high frequency.
That one's working. On overload though. Okay, I gotta turn way down my settings. So what I'm doing is I'm just gripping this. Okay, well that's interesting. It's funny that this one didn't get any sound out of it. Maybe it's got some sort of short circuit. It's possible here. It's got some jammed up sort of components happening. Let me see it. Try it again. Sounds like there's a radio station or something in the background, but it's not very reactive. I need to work on that circuit some more. Well, a little disappointing. It needs a lot more work here as far as getting these things to respond properly. I need proper nano-coating and make sure the circuits are hooked up in a nano-coated way rather than a matter-to-matter kind of way. Let's see what this guy sounds like with this setup. It's definitely loud. Well, I'm going to have to do a little more work on my circuitry, I believe, in order to get things straightened out here. So stay tuned, literally, for more as I get it worked out. I think that this is going to be a really interesting test platform, though. I was able to get more response on it last night when I was working with it, so I'm not sure what's going on. There's something different with the wiring or something different with maybe the modem. I had the modem shut off when I was experimenting because it makes the system so much more sensitive as well. But I'll get a couple more sensors made up with coil systems that we're used to. This is more or less like the health pen setup, and we can try other ones as well. See what's most sensitive. The idea is that what I'm working on actually is to be able to take this test tube and basically plug it right into the end of the iRig device, which will be plugged into my iPhone, and then I'll have a portable way of monitoring and picking up on the fields with it should be able to sense the fields of these coils using a nano-coated coil to sense a nano-coated coil, essentially, is the idea. So next week I'll have this put together so it just plugs right in to the iRig device, and then I have another circuit that will also just plug in directly to an iPhone, so I can either go through the iRig or plug it in directly. I'll see what kind of difference in signal we get with that setup.
Yeah, just some background for the folks that haven't been following us for the last couple of weeks. We're just looking for a way to see the difference. You know, if we can see the difference between two coils, one's working, one's not. That's what we're after more than anything. The numbers don't really mean anything. We're just looking for a change in the output.
Definitely worth persevering with. I think you're on the right track. This is great.
Let's try one more thing here. Oh, that's really amped.
It may also be that Rick's place is so saturated with fields now that the slight change we're looking for is totally buried in the background.
That's a really, really good point, John, and that's true so much. Like just the modem, I just discovered 2 nights ago when I was using one of these devices, like I just put it together, plugged it in, and I was probing around underneath my bench here, and I discovered even though I had the modem shut off, I was still getting this beep, 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 beep kind of, the woodpecker effect, 10 hertz or so, which I know comes from modems. And I'm thinking, how can I still have this modem sound? I've turned off the modem. Well, it turned out to be my printer. My printer, for the last 6 years, has been sitting there transmitting on Wi-Fi. And I didn't know, I didn't have it shut off on the Wi-Fi, basically. So I don't use the Wi-Fi. I have it plugged in directly, with a printer cable to my computer. So I'm thinking that's not good. So I shut off actually it's on right now. So I'm going to shut that off. Still, I still got the modem going, and that's what we can hear. That's what gives that bump, 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 bump kind of sound. It's a little less now than it was, but you're right, that totally interferes.
Yeah, Jay McDonald just mentioned before that the maybe interfering
Is what?
Jay McDonald mentioned that the monitor may be interfering as well. There's quite a quite a bit of RF coming from your monitor.
Yeah, actually, I've used this little radio and other ones that I have, like this little guy, to actually listen to the monitor. I could put it up to the monitor and hear different sounds coming out of the monitor. I've done some YouTube movies like that. Just plug this guy in and see if he sounds anything today. Ooh, quiet. Doesn't seem to be too reactive. And let me try one more unit here. The old brain power beacon box. See what it sounds like today. You can get some action out of it. It's very sensitive. You can definitely hear the modem in that. Hungry?
Yeah.
Somewhat. Oops. Just lost the antenna connection. Actually, it should go through. Oh, that's real sensitive now. So sensitive that anything that switches on and off will you'll hear it. You hear it as that lightning. So I'm not sure what it's picking up on. It could be even probably a neighbor's house when they turn a light switch. Or if there's lightning in the background, it'll pick up on that as well. Actually, I need to turn it down. To get this whole system sensitive enough to detect the difference between the different Gans balls. I think that would be spectacular if I can get it to actually make a different sound with each different Gans ball is my objective. So it's a matter of fine-tuning the system. There's several different systems going on at the same time that need the tuning part. So I'll have to work on that some more. There's definitely a work in progress, and I think there's something that I think it can actually, I think it's possible to make it actually work. So.
Yeah. Rick, have you had it sensitive enough before to pick up the fields in your hands?
Yeah, definitely. Like a couple of days ago, I was able to pass my hands between these coils here, and you could hear the difference. And usually, if I have one of these units and actually hold on to it, then it should make quite a difference actually. And
yeah.
It does make a bit of a difference with this unit when I touch it. You can see the difference. Just turn this down a bit here and let's see if you can hear a difference. It definitely makes a difference. Adds a lot of top end stuff. Let me tune into that a little bit more.
Yeah, that's...
Shot? Could that be a capacitor discharging? It seems to be pretty regular.
Well, it is something like that. Sometimes what happens is this system can pick up on the sounds of the computer, and I've had it so sensitive that I can actually hear the drives going on and all the workings in the computer. It's quite amazing. But right now there's some other interference going on that's more superior to it. Those sharp noises usually are some kind of spark going off. Like, let me see, I'll go turn my light on and off. Maybe this one will work. You hear that?
Sure can, yeah.
That didn't take very long to track down, did it?
So it's that sensitive. It'll pick up on a light switch going on and off at the other end of the building, actually. I could go and demonstrate that, but I won't. Take my word for it. So it's a matter of getting all the components sort of tuned in. Like normally this system here in a crystal radio, you would tune your coil and your capacitor exactly on that radio station that you want to listen to. But in this system, it's quite a bit different. There's other things we're trying to listen to other than a radio station. Reminds me, I could have hooked this up probably to that, but Oh well, I just have to do a little more work on this whole system to get it more efficient, basically.
Yeah, there's definitely thousands of variables, you know.
Yeah, yeah. And I want to get it simple. The idea is that, to me, the coils and the nanocoating, they're almost like a whole crystal radio circuit in themselves. It is crystal, that copper oxide crystal. It is a crystal very similar to the germanium oxide in the little diode. That's the essential part of the crystal radio. And we already have a coil here. We have a coil over here. We have these same setups can be made into capacitors that we've used in the magrav units. We have a capacitor over here, this little, and another little capacitor here. So essentially, all the parts of a crystal radio can be made with the parts of nano-coated materials. And in fact, you can even build a crystal radio with a nano-coated copper cup. And there's a certain way you can nano-coat it with the red copper oxide, and that makes it very sensitive in the same way that the germanium crystal in the diode is. So you can make your own diode with copper, you can make your own coils, you can make your own capacitor and resistor, and essentially you have all the parts then for a crystal radio. So it's a matter of making. One of my projects is to make a plasmatic crystal radio. So essentially, it'll be all copper parts. And so the challenge that I see is, can one make a radio that actually receives stations or ambient energy or whatever, that receives just out of copper parts? And I think that would be a grand thing, all nano-coated copper parts to make a radio.
Yeah.
So
There's those old war stories in the Second World War in the prison of war camps where they made radios just out of what they could get their hands on.
that's right. And one of the things they could get their hands on, one of the only things they could get their hands on that would work for them was razor blades, because they had these single or double-edged razor blades back in the old days, for your razor, and you'd have to replace the blade and so on. Flat, sort of sharp blade. And they would take that blade and blue it by heating it, and that essentially nanocoats it. Okay, so you have a nano-coated steel blade, and they would use that as the diode, as the crystal of the crystal radio. And you make a little cat's whisker thing, a piece of wire that comes out, and you probe this nano-coated razor blade, and in a certain spot, when you have the rest of your system set up, it'll have just the right semiconductor status, basically, to make it very similar to makes it very similar to the diode in the crystal radio, which is so essential. So they would sit there in the foxhole. They call it a foxhole radio, and they'd have you'd have your razor blade, and you'd have your little probe for the razor blade, and you'd have an antenna. So what do you have in a prisoner war camp or in a military place or whatever? What do you have available in the foxholes and on the battle fronts and so on? Well, you almost always have barbed wire fence around, a perimeter fence around the compound. So guys would hook up their little radio, because you had to have a good antenna. That was essential. And you can't blame these guys. They're craving some sort of input from the outside world, right? They just want to hear.
Got plenty of time, yeah.
They want to hear what's going on out there, or maybe hear a song, or just some sort of secret information that's given on the airwaves, or whatever, anything. So they'll hook into this perimeter fence that goes around the compound. That's the antenna. Of course, the ground is, you can drive a stake into the ground, a copper or steel rod or something, and that would be a ground system. And you got your ground, the antenna, you've got your crystal out of the little razor blade, and then you usually need some sort of coil. So they'd use whatever copper wire they had and wrap it around a toilet paper roll or some sort of round surface. The oak boxes were used in some crystal radios because they were round. And then you have basically all the components right there in your foxhole. Aside from the headphones, you needed a sensitive pair of headphones, and sometimes even they could be fabricated, but generally they'd have some headphones around that they could procure or use, and they tune into these stations and so on. Of course, the military frowned upon that severely. In fact, it was a severe reprimand for that kind of thing, because it turned out that if you had a radio, then the enemy could tune into your location by triangulating your radio that was receiving the waves. So these guys inadvertently might be targeting their compound by setting up these crystal radios and trying to receive something and so on. I'm not sure if that was a big problem or not, but apparently that could be done. But yeah, that's right. People have tried all kinds of different things for crystal radios when they're stuck in a crunch. And when I was a kid, I had a little chunk of germanium crystal, and you'd have a cat's whisker little steel wire probe that would stick into that, and headphones and antenna and the ground and a couple other little components, and bingo, you'd be able to actually tune into a local radio station by probing this crystal. Okay, so
yeah, there were some stories of people that would have some weird dentistry and end up hearing the music in their heads, and the fillings that would set up a receiver, and that would drive them crazy. They wouldn't know where this music was coming from.
That's right, absolutely. That's why it wasn't working. All the way. Yes, that's right. That sounds pretty crazy, but inside our mouth, it has all the conditions, essentially, of a crystal radio. Once you have your fillings as especially if people have talked about putting tin foil up against your filling. Well, the aluminum and the amalgam, or mercury plus silver in the fillings, would set up a circuit with the acids in your mouth, and basically you have a little battery plus the nano-coated surfaces of your tooth and the aluminum and so on, or even without the aluminum, and bingo, you've got this circuitry, you've got the power for the circuitry. Our bodies are a perfect reservoir for radio fields. They pick up radio fields, and you could, they're latently sitting there ready to be tapped into. All you need is the right dentist or the wrong dentist, because it would probably drive you crazy to be hearing most of the radio stations that we have out there full time without being able to turn them off. Pardon me?
Hard to change stations, standing
Yes.
on one leg, lift your arm.
Yeah, exactly. Maybe if you eat certain foods, it would tune in certain stations. That's a strange concept, but it is possible, technically, I suppose. Okay, well, like I say, I'm going to have to play with that some more to get better effects out of it, which I'm sure will occur. It's just a matter of getting the right setup. I've got a design actually, or idea for another setup. Well, basically it's using a coil here, another coil beside it, and they will both be plugged into the audio circuit. And then you can put things in between these two coil setups to because there'd be a field between the two coils. There'd be like an infinity loop between the coils. One would be the magnetical, one would be gravitational, in a sense that create the field between them. And that's really a way that could work. We could use the same coils as the magrav units, be similar to the health healing unit, where you have a coil over here and a corresponding coil and the plate on the other side, and a person stands in between the two to receive the fields. And that could very well work, and I'm thinking might have a saltwater grounding system with this, like a bucket of salt water that the plasmatic wire goes into as a grounding structure. Maybe that's the way this system needs to be grounded to work properly. Okay, well, a bunch of ideas. We'll see how it goes, and I guess that's about it on that for now. Any questions or last minute stuff on that before we carry on to something else?
Just thanks for sharing it. It's really cool and want to see it go ahead. Yeah, it's awesome.
Yeah, just needs a bit of work, and I think it could be really, really cool. See, Don Graham says, Rick, I cannot find the Zoom notification. Okay, be the same as last week, same Zoom number, 963-135.
I figured it out.
Oh, you're here. Okay. Oh yeah, I see you're here. And in Zoom. Good. Okay, and so anyway, that's it on that particular thing right now. What else is kicking around here? Well, you can see my t-shirt here. We replicate the same technology as the universe. I put together some t-shirts for the workshop that was happening locally, and that was a big hit.
Is that shameless promotion going on here?
Well, it's in a way, but it's not. I was shamelessly promoting the Keshe Foundation in the workshop, even though it's not a officially sanctioned Keshe Foundation workshop. It's a plasma workshop, and with Whitney Fisher and Carrie Ellis, and they came up from, well, they started in Florida and just hit the road and knew they were going to do workshops and didn't really know where exactly all the stops were going to be and everything else, how they're going to, if they're going to be able to pay for it all and so on. But they made their way diagonally across the United States and then up into Canada and back down into the States, and I think they're busy doing a workshop either now or next week, or I mean in a couple of days.
I think they just finished Yelm. I'm not sure what's after that.
Oh, they finished Yelm already. Okay. Boy, they're busy. They just go for it.
They posted some photos wearing their t-shirts and, saying thanks to you for that in the golden age of Gans today, I noticed.
Yeah. Okay. It's great. They're doing really good, and it's amazing how it comes together. I think especially with the ladies that put these events together, they make connections with other women, and all of a sudden they just mesh, and they all form like a unit and pull it off really well. And I know men can do that too, and lots of men are running workshops and all that. But I don't know, I'm just amazed how women can more naturally multitask and take care of multitudinal details easier, at least easier than I can. I'm not perhaps the best representative of those that organize things. There's lots of men that are great organizers. I'm not one of them. I can organize some things, but you know, it's
They're just
a challenge.
better networkers, you know. They kind of know what's going to happen before it happens. So, you know, they got the advantage over us. We're more sort of danced around the fire with spears type of communication.
Right, yeah. Yeah, if it doesn't bite us or step on us, then we don't notice as much. So, okay, well, let's move along. Let's go back to Lee Coates, and unless someone else has something they would love to present right now. Going once, going twice.
Well, Renee asked about showing his system, but he doesn't seem to be on anymore.
Oh. Okay, Renee, if you're hearing our voice, within range of our voice, if you can come back on, now's your big chance. Otherwise, let's go to Lee and see what Lee's up to. Let me, I have to pin it. There we go.
Just gonna share my screen first to show you what this is all about. About I don't know, 6 weeks ago or so, I came across this blueprint posted on the Golden Age of Gans, and it's about gold particle production using some spinning balls and a bottle of gold Gans. So I started this experiment to try and replicate it. The problem or the challenge here is to get your balls totally centered, and so they spin, because this has got to spin 24/7, and it's spinning at I don't know, 6,000 to 8,000 RPM, fairly fast. So you got to get them centered so it doesn't vibrate. My first setup here, I had motor failures. The motors I have are sort of low RPM, about 2,000 RPM. So I was running them with pulleys here onto the shaft, and I got one up to about 5,000 RPM, and then the motor overheated and failed. So that's. And then I was at the electronics store, and they had a whole range of different fans, right from little baby ones up to bigger ones. Some of them are plain bearings, and some are ball bearing shafts and all that kind of stuff. So I bought a couple of fans, but I haven't got around to making the adapters for them to get my balls on them. And then at our dump, or their sanitary landfill, they have a second-hand store. Basically, people can donate junk that's just a little bit too good to throw away, but it's junk. And I found well, this motor came out of a cordless drill that didn't have a battery. It cost me $2, and then they had about, I don't know, 4 weed whackers in there, battery powered weed whackers. And so they didn't have batteries or anything with them, so they're total junk, really. But I bought them for $1 a piece to get some motors. So,
wow, they must be powerful motors, eh?
Yeah, well, some of them, like, they're direct drive. Some of them got this one had another shaft on here to the head, and then it was geared.
Mm-hmm.
So anyway, I found a source of motors, so now I can play some more. So that I sort of update you on.
What's your belt drive there? What kind of drive system do you have? You have a shaft with, what, 2 bearings in it that hold your ball assembly there?
Yeah, so
and
that's
then
what I tried here, because the motors I had, like a year ago, we were spinning our ping pong balls in the spaceship reactors at about 2,000 RPM or less.
Right.
So all my motors were low RPM motors, basically.
Mm-hmm.
So I just tried to pulley arrangement.
So how'd you get the pulley on? You made a pulley, or did you buy one, or how did you get it onto the shaft of the motor? And is it a rubber O-ring that's driving the?
Yeah, it's just a rubber O-ring, and you can buy pulleys on AliExpress from China, different
Mm-hmm.
diameter pulleys. So I've got about 4 different diameter pulleys
Okay.
that drill out the center to fit your press fit over the motor shaft.
Oh, you just press fit it over the shaft. Okay.
Yeah,
Mm-hmm.
that's all I was doing. But
Yeah.
it didn't. These motors weren't. They weren't. They were overheating.
Mm-hmm.
What the problem was, and one motor I wrecked it. It was spinning at 4,000, and all of a sudden it dropped down to 1,000 RPM, and it was really too hot. So
Yeah. Yeah. I burned out a couple of motors myself as well.
so this first setup didn't work. So I got to try with some of these other motors and try something different. So just thought I'd pass on the, at the electronic stores, you can get all kinds of different fans and
There is
the
quite a variety of those
secondhand
fans.
stores.
Yeah, there's a lot of different ones of those fans. Like you say, some of them have ball bearings, some of them are sleeved, and some of them are 12 volts, and some are 5, and other such things. And some of them have a variable speed on them, and like a control unit that actually comes with it. Some have lights built in that flash lights in 7 different settings. And so on. It's all part of the people that modify their computers for high performance, and so they overheat, and they have to put on a high performance fan system with up to 4 fans blowing and so on.
Yeah. So anyway, that's the update there. I got a.
Do you have a controller for your fan? How are you going to control the speed on your fan that you picked up there, the black one?
I'm just gonna run it through the motor control here.
Oh, okay.
Yeah.
Which
Pulse width modulated motor controllers are cheap. You can get them, $2-3 a piece for 10
Yeah.
or 15 amp controllers.
Yeah, that was my question. If he was using a speed controller. Yeah, thanks for that.
you can get pretty nifty speed controls for those fans, actually. If you look up computer fan control, you can get a 1, 2, 3, or 4, or I think even 6 switch control unit to control up to, well, definitely up to 4, I think up to 6 fans separately, with an RPM readout for each of them, and a nice little, control for the speed for each, and so on. So that's another option. They're not that expensive. For $50 or so, you can have a decent little control unit.
Well, as soon as I get my first ounce of gold, maybe I'll go buy one.
Yeah, right. Well, an ounce of gold would take care of that quite readily, yes. Even a gram would be nice to see. Even less. Just the color. A flash in the pan would be fine. Good luck with that. It's a grand experiment. And so, tell us what you have in the little bottle there again.
That's some gold Gans.
Right. And that's some real stuff that you made yourself, I guess.
Yes.
Right on. And tell us a bit about how you made that, maybe.
I had a couple of gold coins, and I nano-coated one of the coins, and so I had it in the salt water. I think 3% salt or something like that, with less, just under a volt of voltage between the nano-coated coin and the non-nano-coated coin.
I see. Mm-hmm. Under a volt. And how long did it take to make the Gans?
In a couple of days, you got about this much Gans.
I see.
So.
And did you lose some of your gold coin? Was it noticeably deteriorating?
Actually, I can. It didn't seem to lose. It didn't seem to lose anything really.
Mm-hmm.
But
Did
it
did
must
it
have. But you
did it
know.
did one of them sort of get corroded a bit and one of them clean? Is that what happened, or what it looked like in the?
Well, I had left them in the water for a month, and
Oh.
it got pretty dirty. But I just took a wire brush and cleaned them up, and I was sort of surprised that you could still read all the writing on the coin and all the,
Yeah.
it wasn't corroded to speak of. I'm sure it lost a few
Atoms.
molecules
Mm-hmm.
of gold off it, but
Sure.
I couldn't tell from where. It wasn't like it was pitted or anything. It was still
Right.
smooth and
Well, it's
so on.
interesting, and it begs the question: how much gold Gans can one create and still get away with the coin being worth as much as you started with? So
Well,
you have your
this is the
Gans
oldest game in the
and
world, shaving bits off coins. Yeah.
yes, well, it's not such a crazy idea. I mean, people have done this, I suppose, to make you could dip your gold coins and get the gold off in the solution and then precipitate it out or something. But I'm assuming with gold coins they would probably, if you were to take it to a bank, they might even weigh the coin to make sure it weighed properly or something like that. I'm not sure about.
Spectral analysis or something. Yeah. Go, hey, you three,
Well, also
knowledge.
though, there is normal wear and tear, and a coin can definitely, I mean, an old gold coin that got passed around a lot would have wear on it that would alter the weight of it significantly. So some coins might be only half the weight of when they started, if it was used a lot, especially if it was dipped in some sort of solution a lot, and someone taking a little bit off here and there. No, it's interesting though that you have your Gans and you still have your gold coins. It's a win-win situation, I believe. So far, so good. Maybe you've created gold, and and it's right there in front of you. Maybe it didn't take any off the gold coin, and it was able to still create the gold Gans. I'm wondering. It'd be good, I guess, to weigh the coin to some sort of exact number if you had a super sensitive scale, and then actually make the Gans and then reweigh the coins and see how much, if any, was lost in that process.
Yeah, I don't know whether they weigh them at the coin store or not when you take them back in, but anyway.
Well, generally, they wouldn't be weighing any of the other than gold coins. They would look for wear. You can tell by looking at it. In fact, if they're good at the coin store, they'll be able to tell whether it's even been cleaned or not. And a coin that's cleaned is almost worthless compared to one that's not been cleaned. If it's been cleaned, it devalues the coin to 20% of what it was or something like that.
Yeah, those are the fancy coins. The coins I was using were just bullion coins, so it's a question of how much they weigh. Really.
What they probably do, if you had a bunch of them, they might weigh the whole batch, but then they have to account for normal wear and tear, and they can't charge you for wear and tear. Sorry, you use this coin too much and it's too worn out. We can't take it. So
well, bullion coins, you're just supposed to keep them in your safe, as you're not supposed to use them.
Oh, I see. Yeah. Well, that's a good point. They might ask, where exactly has this been getting its wear and tear? Well, I keep it as a good luck charm in my pocket all the time. 4,000 coins, sir? I have a lot of pockets. They're very deep.
They're a little too expensive in case you lose them.
Yeah. You want to have a hole in your pocket in that case.
If you dried out some of that gold Gans, would it turn white powder and you have monatomic gold that's $4 million a gram?
I don't think so, but who knows?
Well, the Gans should be monoatomic, though, right?
Well, this is a good question, actually, and I don't think that all the GANs is monatomic necessarily. It could be because if it was, well, we have to sort of define things in a way, perhaps. If it was actually monatomic, then we wouldn't be able to see it in the solution. We can see actual chunks, so obviously there's a amalgamation or a congregate of these particles that have come together in order to make a visible particle. So there might be, thousands or at least hundreds of the particles coming together to make something that's visible. So I wonder about the monoatomic, and then also if you're talking about copper oxide, for example, would that be copper oxide as one single CuO? Well, it's a molecule, it's not an atom. It'd be one atom of each element in the molecule, but it's not Cu and O, it's CuO. They're combined as a molecule. So is that a monoatomic molecule in that there's one atom each? And if it was Cu2O, the other copper oxide is CuO2, then does that make it, because there's two atoms, it's not really monoatomic anymore. It's monomolecular perhaps, but even that is dubious because they'll be linked together in crystal structures usually, and that's more than one atom. There's multiple atoms in crystal structures. So what do you think? Anybody want to weigh in on that?
I just think the monoatomic gold, I could be wrong, but I believe there's a heating process involved in getting that white powder that they'll call monoatomic gold. That there's a few videos out on it, but I've got them. I just haven't had a chance to look at them. Yeah.
Well, certainly what's called ormus or monoatomic gold is something that is of stories that have been around a long time, and it seems to be kind of a difficult thing to create it properly. There's a lot of people say you have to do it under just the right conditions and under a full moon and at midnight and so on, literally. I've been invited out to learn how to make that material with using seawater, and I think it's with caustic, but I'm not clear. I haven't been shown the process yet, but it has to occur during the full moon. You have 1 or 2 nights, depending, that are able to be done each month, and it has to be at night and so on and so forth, and there's a whole procedure that goes with it to create it. And I've seen other procedures that are quite scientific in terms of the chemicals you use and so on to create it as well. But I'm not sure if that's the same substance as like what Lee has there. I think it would be a different substance. As far as that's kind of a brownish or goldish looking material. Is that right, Lee?
Yeah, it's
It's clearly tied down.
Yeah, I was gonna say, look, it's got anti-gravity effects too. Well, it's kind of a honey sort of color, or what would you call it?
Yeah,
It's not orange, is it? It's almost burnt orange looking from here.
yeah, it's a burnt orange. It's a little darker than the gold on the gold coin, more orangey. Not as red as the CH3, but
Yeah, so So the ormus, the way I understand it, I haven't seen it myself, but it's supposed to be white, right? White powder. Is that correct?
Yeah. They were getting at Fukushima. They were getting a white gold, a white powder, or a white Gans. You know, when they converted the cesium to gold or whatever. So there's different ways of doing it, I guess. Or
Yeah, there's the whole story of the gold white powder. Goes back to the Egyptian pharaohs that make like a bread out of it or manna out of it, feed it to the Egyptian pharaohs, and it was about long life and longer
Right.
life and increase your intelligence or your psychic abilities.
Yeah, they made the bakery next to the mines apparently, and so they could um, use the gold in the baking, and but only the king got the good stuff.
Yeah, yeah. Yeah, apparently there are some places that found kilns and they pulled apart the bricks in the kilns and found this white powder under the bricks, and this was back in the 30s or the 40s. They didn't really know what the powder was or bothered to test it. But they believed, well, some believe that that's what they were talking about, the mana or the white powder, which, links to that some will say that the Ark of the Covenant was all about making that white powder.
Okay. Well, maybe you need some bleach, Lee. Who knows?
I'll settle for the yellow stuff.
Yeah. Who knows? Bleach could actually work. Ammonia is one of the things we haven't really experimented with yet. I mean, it's basically nitrogen. And I think it's bleach is what, NH3? No, what is bleach? I have to look it up. Yeah. Because I mean, we use caustic and we've used other, different things. Somewhat, some people have to try to come up with different things. It's. I guess I was thinking of something else. Bleach is NaClO. Instead of NaOH, it's got Na and O, but instead of the H, it's got a chlorine. Sodium hypochlorite, actually. Strong oxidizing agent. So it should be able to do essentially the same thing as the sodium hydroxide, I would think. But be careful at home. The Wikipedia says there's about 3,300 accidents needing hospital treatment caused by sodium hypochlorite bleach solutions each year in British homes. So be careful if you're in Britain. You never know when they'll be throwing a bleach party. Okay, anyway. So, Don, you've got something on your video there. Did you want to show that? Was that something special? I didn't know whether to put it on or not.
Yes, it is.
Okay.
What I have over the past 5 or 6 years, I've been kind of making a study of how to get my body back to perfect health after abusing it with women in song over 40 years. And I've been relatively successful in that. I've tried many different brands of vitamins, organic vitamins and brand names and so on and so forth. And I'm sure everybody realizes that, one vitamin is not equal to another or manufactured to another, nor are our bodies exactly alike. Vitamin C might work for me in my body, but it may not work the same way in your body. Well, in my travels, I started studying the food GANs that Keshe Foundation has been instructing us on, watched many YouTube videos and read a bunch of articles and so on. And I came to the conclusion that it's kind of labor intensive in that you got all the grinding and the cooking and the caustic and on and on and on. And what it dawned on me is that you're taking a vegetable that is not stocked with the necessary vitamins and minerals that a vegetable, say, back 50 years ago had. You know, the soil has been depleted with all this chemtrail going on. I'm sure that has a definite effect on vegetables and minerals and so on. Well, in my travels, I managed to come across the product you see on your screen right now, which seems to be the ultimate in collection of vitamins and minerals. Now you'll notice the blue tape on there. I know we don't promote products on our meetings unless it's a Keshe product. So this product will go unnamed as of today. And you can see the long list of material there that are in perfect balance. And then if you look over here, there's a list of more of the stuff that's in this particular tablet. So what I did was I took 10 of these tablets, ground it up in a mortar, put it in this glass container with my NaOH and made a Gans. And you can see from the label there, I don't know if it looks like all the lettering is backwards. Must be a Oh, okay. On my computer, it's reading backwards. But anyhow, I made the Gans, and then as you can see, I add a few things in addition to that, calcium and CuO, and I use the water from CO2 as the liquid. Then, figuring that this is a very concentrated, very well-balanced Gans or food Gans, I decided that I was going to use something that I found in the discontinued bin at the local store, and it's a, as you can see, it's just a glass and has this dildo-looking thing here, and I made a metal coil to wrap around it, which I'm having a heck of a time getting it to take to nano-coating, cold caustic ways, but it'll eventually take hold. And I was going to put this in here, Exhibit A, and fill that up with my new invention and see if I could not introduce my body to a completely balanced vitamin mineral infusion, to be continued at a later date to see if in fact I've accomplished what I want to accomplish. And that's basically all I have for today's show and tell.
That's great, Don. That's interesting development there. That could. So in that glass, it has holes in that inner sleeve, or does it not have holes? Those are holes, right? Oh no, that's printed.
This is just a cute little whatever on there.
Right, I thought it was holes, but they're not holes. They're just,
painted.
They're just painted on the outside. I see. Thought it had holes on the inside.
Of course,
so
I put them.
Sorry. Go ahead.
And this just goes inside here and screws down.
Right. So you have the coils, and you'll have the actual Gans material in there, or the Gans water, do you think?
The Gans water, because in fact, the Gans, I put the CO2 in here as the water source because Mr. Keshe had mentioned that in one of the teachings that it's a way of collecting all of the, what are we talking about, plasma, good stuff, into a liquid form, into the liquid plasma. And you can kind of see from on the bottom here, you can kind of see some of the other Ganses that I've added to it sitting on top.
Mm-hmm.
You know, because the other Ganses I've added were white in color, and the actual tablets turned out to be this brown black kind of a color. If I shake it, I can probably.
What color
As you
did
can
they start out as? Greenish sort of color, or what?
kind of a greenish hay color or straw
Okay.
color.
So it darkened
And
them up and made them brownish then, yeah.
yeah, yeah. So, and I put it out in the sun, like, you know, is recommended, so I can pick up a little of God's energy with it. And we'll see if that, if I become even more healthy. What I'm hoping is that it's gonna act as a food source and instant diet at the same time to get rid of this beer belly that I got.
Mm-hmm. Huh,
So,
interesting.
multifaceted approach.
Mm-hmm. Yeah.
But
All right.
that's all I got. Over.
Thank you, Don. And so I'll start my video so we have something to look at. And there we go. Okay, so what else we got lined up here? Anybody else want to do? We have Son Kim has his hand up. Son Kim, do you want? So yeah,
Okay, can I ask Lee a question?
absolutely.
He has some gold gansers. Has he tried putting like a butane torch to it? What happens?
No, I haven't.
Because gold powder looks exactly the same color, and heat to it, it turns back to metallic gold.
Yeah, and I'm not. If it was gold powder, it would melt, but I don't think the Gans will melt under heat and turn back to gold. But I've never tried it, so I don't know.
Yeah, it's an interesting question. What would happen to it?
What was there ever try to burn Gans before?
I think you'd probably have to dry the Gans out first to powder, and then torch it or something to see what would happen.
One point, Here's Martin. Hello.
Hi, Martin.
About this point, in the market, the liquid form of gold is much more interesting than the metallic ones. So you have better prices. So you should not. As this is not I think it is not a problem then to have the metal, but you will lose a lot of value. So you should search people who need that kind of solution that you make. This is my take on that. And
you're saying that like you can buy nano gold in different colors and shapes and so on. That's where the market is. That's where people are companies are charging good prices.
In the industry to process the things, you need it in solution, and this is much more. The price is much higher than the normal gold. So
right.
When you have now the pressure to bring the yellow metal, then you will lose a lot of value for yourself or for the industry, and then they have to bring them back to a usable form. So it's much. It's much better to have in solution the things.
Unless you can create some particular structure on the gold, and when it's turned back to the, more or less matter level, maybe it will have instead of being a certain structure, it'll have a different structure that will cause certain effects. Like we do know that when gold is reduced down to, I think it's 30 atoms of gold in one cluster, makes it into a nano size, and it has totally different properties at that point. It becomes magnetic or paramagnetic, diamagnetic when it wasn't before, and so on. It develops different properties due to its nano size, and that just in a particular narrow sort of bandwidth of numbers of atoms, basically, because it forms structures. It can form pyramids and different structures that resonate to a different degree and interact with light in a different way and interact with everything in a different way. The same goes with all of our nanomaterials, especially the copper oxide. This is what we need to experiment and measure more, is what are we creating on our surface? What does it actually look like, and what can we make it look like? Go ahead, sorry.
You know, then with the acids and all these reaction tools, you create the hydrogen, and this is the oxidizer, and the hydrogen also is the copy machine of the nature. So every form you have then in your solution will be copy in that moment when it contacts the hydrogen. And so this is also the thing that we see in the reactors when you have hydrogen reactors to make brown gas, even in low values, and form you create every time the solution that you have in the bubbler. So if you have a mix of salts or acid, whatever, you create exactly that mix when where the hydrogen bubbles through, you know. And so this is very, I mean, for me, very interesting. So you have really a copy machine on hand, even if you make now that with the Gans process, you know, it will be the hydrogen who will be the multiplier of the material, you know, not just the field, but the material too.
How do you see it as the multiplier? What is the mechanism there that you see?
I see that the hydrogen is the quickest and the finest gas, and so it is like the source. It is the how it calls. He searches after breaking apart. He can stand forever, or you can he can bound himself to the next possible solution or the next possible body. And when he contacts the body, then he reacts. He make that reaction and will coating the surface and will become like the diamond, and then the next water molecule will go over and make that chain reaction. And I think, in my view, it is in all these reactors and batteries and whatever, you have that process, and you will always copy the solution that you have there, or the metal that you have there in that package. Even if you have alcohol inside, you will make more alcohol out of the bubbling process. And if you bubble the brown gas or the hydrogens through your body, you will copy exactly the same structure inside you. And this is what is in the science of the brown gas. You will come over those studies, and I think it's very interesting, you know, to see that as a space, as for myself, to see the problems and the possibilities about the power of the hydrogen.
Well, definitely the hydrogen comes up regularly in the Keshe teachings, you might say. Right from day one, where hydrogen was always the central core gas in the gaseous reactors that were rotating and whatnot. The heavier gases go out to the outside parts of the sphere, whereas the hydrogen stays at the center core. Well, actually, the free plasma is at the core, but the hydrogen surrounds that free plasma. Becomes
it is the reactor. As I mean, I think if you have the acids and all these reactors, you have the hydrogen then who will be the new, also who will split, who will be the reactor, you know, who will make the reaction, and then the process who follows is commanded by them, because he's in charge.
right. Right. Yeah, it's very interesting, actually. I mean, if you look at just water alone, normally, H2O, two hydrogens, one oxygen, bound in that particular angle. What is it, 109 degrees or something? The polar molecule of water, called polar because of the angle. It gives it essentially if you look at it plasmatically, then the plasmas they have a direction. The whole molecule is going, it has a charge that's going one way. You could look at it positive, negative, doesn't matter. It's just do the geometry with a hydrogen down here and a hydrogen here and an oxygen in the middle. Then it already forms a wedge. It's going to go with that leading the oxygen and trailing the hydrogens, just because of the way it's charged, and it'll oscillate as well. But what I was going to mention is each of those hydrogen, oxygen, water molecules spontaneously splits every 20 hours or so, I think is what they measure. And it spontaneously ionizes. Water is self-ionizing. I thought, geez, I only found that out a few months ago, and I thought that's incredibly amazing that every so often, every 20 hours regularly, or roughly, on average, put it that way, each water molecule ionizes. It just momentarily splits apart, and the hydrogen loses its becomes an H plus basically, and the OH, but it actually is a little more complex than that. But basically, it self-ionizes, and we have that ionized hydrogen sitting there, ready to, if we could only just get our hands on it and separate that ionized hydrogen, which is what we would like to have in the center of a reactor, for example. But what happens is that self-ionization process is so instantaneous. It's actually the fastest chemical or fastest reaction, I think fastest chemical reaction that they've ever measured is the recombination of that ionization that spontaneously occurs. So you got this splitting and then bang, back together in a picosecond, a few picoseconds, something like that. Very, very short time interval. So short that they could never measure it before, and they didn't even know that water was self-ionizing until recently, apparently, because they didn't have the tools to measure that time frame. They couldn't take a picture of it because the frames were way too many frames per second, and so on. So I think that's quite amazing, and I ponder, for example, if this was a rotating Gans water reactor, and it's rotating and rotating for maybe days at a time in some circumstances. And what about that relationship to the water inside, which is basically the heavier parts of the water, because water's not always consistent. The temperature alone determines the density of the water. So the colder water is going to go to the outside as this is spinning because it'll be heavier. It'll tend to be the warmer and more active, the higher energy will be in the center of the sphere as it's rotating. But what about the fields? And what about this self-ionization factor? Because it turns out that the self-ionization of water occurs due to random fields that are occurring in all water everywhere, because all water self-ionizes. And it doesn't matter where, it's just the tiny wee fields that are self-existing everywhere. Every once in a while, this field that's going along will combine with this other one that's going along, another one, and it provides a peak. And that peak of energy on a micro scale on just that one atom, or one molecule rather, not the one adjacent to it, not the one over here, but just that one molecule catches that peak. And bingo, splits apart, comes back together. Instant ionization and instant recombination with a couple of other side products that are created besides just the H and the OH. It's a little more complex. It's like a complex molecule that splits apart, but it's still an ionization process, same thing. And so what about in the spinning ball, spinning ping pong ball, or any spinning globe with water in it, is going to undergo self-ionization in there. And if we can focus the fields, these peaks that occur naturally just from all the fields in water everywhere anyway on a micro scale, but if we can just say civilize these, not civilize, make them less random, to make them coherent in a way, in the same way that laser is light amplification by stimulated emission of radiation. It's a coherent beam. If we can make a coherent field that activates that self-ionization process in the water, perhaps in the core where it's the free plasma would be, let's say, then maybe that's a way to think about it. That would be, an interesting factor if virtually we can create ionized hydrogen in the center core of our rotating reactors. It may take a certain amount of time, like maybe it's an accumulation process where it actually, at that center interface, that center axle, all the hydrogen's trying to get there and all the heavier stuff's trying to get away from there. So it's a struggle for these hydrogens to work their way toward the center in a way over time. But perhaps a little spark here and there from this self-ionization, and that hydrogen separates and it's at the center, maybe it'll stay there and accumulate those higher hydrogens. At least the molecules would have more of a tendency at the center to do that self-ionization than at the edges. So I think that's an interesting factor. The other idea that comes to mind is if you were to stick a needle through here, which I did earlier, to fill it full of Gans. If one was to pull out some of that Gans and make a pocket in there of a vacuum, then that vacuum will tend to want to pull off the water molecules. The vapor pressure of the water will fill that vacuum. Essentially, the water will want to try to boil under a vacuum. So essentially, you would have this pocket of boiling vapor, or near boiling point vapor, so that the gases of the water are already popping off the surface to fill that vacuum void that you've created. So you have the physicality water, or in this case plasma water, and then you have the voidness space created by sucking out the water itself, the plasma water, and that would make it plasma vapor. So then you'd have a plasma vapor core, and if you could seal that after pulling out the needle so it didn't recreate an air pocket back in there, it was just the plasma water vapor and no atmospheric air, right? So, and rotate that, so it would make sense that you would still have water molecules in that plasma vapor as well as plasma vapor, but those water molecules, because they are freed up and in that energy field, may self-ionize much easier than the water molecules, because they're already freed up in the vapor. They're 1 degree of freedom. They have more elbow room. So once they have more elbow room in a vacuum state, they should be able to separate much easier, travel longer distances for the molecules when they do ionize, and create that ionized free plasma in the center that would be so interesting to experiment with. So I think I've talked myself into it here. I have to do it now.
Thank you.
Ways to spin. Okay, so anyway, that's an interesting thing to think about. It might be all it takes is just spinning it is enough without having to do anything else, just from its own self-ionization. It wants to ionize.
Yeah.
So, Rick, I just wanted to quiz you with your experience of motors and spinning these things up. I mean, I know from experience that if you're looking, we're shooting for something around 10,000 RPM, and if you're planning to run it for any amount of time, realistically, you run these things at about 80-90%, for them to last any amount of time. So I mean, idealist, my idea would be to get motors that have an RPM rating of around, I don't know, 1,200, 1,300, 1,500 RPM, to expect them to be able to last any amount of time. What's your
1,500, or you mean 15,000?
15,000, sorry, yeah.
Right. Yeah, I've burned out lots of motors, definitely. And
Yeah.
the secret is, like was being discussed earlier, is you gotta have, things have to be balanced. I'm just trying to find something here. Okay, this will work for that part.
When you're saying balance, you mean like centralizing cores?
Oh, there it is. Okay. Well, like for example, I got this little cheap thing. It's basically a sort of a dollar store. It did have fan blades on it, but whenever I see fan blades, I usually pick them off these days, especially if they're little rubber ones. And you tear them off, and you get this little rotating thing in the middle. And I can actually even turn it on here. So it's rotating pretty good. It's got some pretty good strength. It runs on a couple of AA batteries, and it's got a nice feature where you can you can set it down. This locks in place in different angles and so on. So it's conceivable that one could take a ball and simply glue it on there, and away you go. Actually, it looks pretty good at the black and white and so on. So the idea is that, how do you glue it on? How do you do that? So the thing about the balance I want to mention is this ball with the Gans in it is pretty heavy. It's, I think it's about 10, 20, 30 some odd milliliters. So it's like 30 grams. It's over an ounce of ball here, right? And you put that on a little motor like's inside this. You can imagine the size of that motor in there. It's not that big, and the wires are tiny going to it. So it's not a very heavy duty motor. It's meant to have a couple of little blades on here that are pretty flimsy, and it's not meant to be out of balance. It's already pretty balanced. You put this on there, and if it's off a little bit, like any more than 10,000ths of an inch, or a tenth of a millimeter or something, then it's going to vibrate, and the whole thing will want to vibrate and travel across the table and shake and whatnot. And whoa, and then you lose your Gans ball like that. But what happens is the shaft will start to wear inside the motor, and the vibration could get worse. It could even get quieter for a while it's wearing and so on. But what happens is it just throws everything off, and the brushes will wear funny on the motor, and the bearings will wear out, and it'll be shot. So then, and this kind of motor won't go up to 10,000 RPM either. It won't be happy at probably more than 1 or 2,000 with a ball this size. So then you get restricted. I mean, you could always put 12 volts into it instead of 3 volts, and it'll go 4 times as fast.
Well,
But
how
for
long?
not very long. Yes, it'll tend to burn the brushes and things. So then you can move into something more like this, for example, which is for little remote control race cars that for dirt tracks and so on. These little buggies that they have, they're about yay big, and they really 4-wheel drive, and they jump and so on. So it's a very strong, durable motor, and it's got a cooling fan built into it, and decent bearings and so on. It's made to last quite well. So you could put this on the shaft and have it wobble a bit, and probably get away with it for quite a long time. Again, how long is quite a long time? Are you going to run your unit for a year straight, or are you going to run it for a couple of hours, or just for demonstration purposes, or is it just going to be running full time to try to build the fields? And then the question comes up, do you want a motor close to where you're trying to build these fields, or should it be a certain distance apart? And my experience has been with using a crystal radio pickup, similar to what I showed here earlier. I can move it about, there's a camera, move it about, this far away from a motor like this, a brushed motor, and you can start to hear the interference, and move it in close, and it was quite loud in close, and it drops off quite significantly as you move away. You could still hear it out here, but it wouldn't be as much of an interference as like really loud in close, and then pretty good out here. So I figure somewhere around this distance, about hand's breadth away, something like that, would be about right to stop any interference from one of these units. There's less interference on the top, actually, than the sideways of these, I found as well. So I'm still thinking it would have to be something like this in order to properly separate. So something like Lee had was interesting, where you have the motor down below, and then you have a belt drive that goes to a shaft that goes up to your unit that's up above basically.
Yeah. I mean, obviously, the further away, the more torque you're going to get on the shaft. So you need bearings top and bottom to
That's
realistically
right.
get up 10,000 RPM. Yeah.
Yes, and you have to have pretty good bearings to take 10,000 RPM. Most bearings, the cheapo, bearings you get and so on might not be designed for that application.
Yeah.
And certain miniature bearings are, and you have to decide whether to get shielded or sealed, or shielded and sealed. And shielded means less friction, but sealed means it keeps the dirt out, but it also means there's friction and it takes more energy to run the bearing.
I've seen people online talking about washing the oils out of the bearings to get them to run faster. But obviously,
run faster for a while until the little chips come out of the bearing race and out of the bearings themselves.
Exactly.
For example, this little guy here, it's got special bearings that I got. They're almost like skateboard bearings, which I've also used, but these are special high-speed bearings. Skateboard bearings are tempting to use, but they're not designed for really high speed. They're designed for sort of a medium speed, and they have big clearances between the balls and a lot of slop, so that if dirt and stuff gets in, it doesn't jam it all up. It's designed to sort of work in dust.
I was using rotor bit bearings. Rotors spin at about 20,000 RPM, so
yeah, even up to 30.
They should last.
John, that's a great idea. Yeah. Yeah, because I mean, there's a lot of variables to this, and if I'm going to do it, I want to give it the best chance I've got. And I just thought I'd ask you guys, because you've done a lot of this stuff.
Yeah, I've just bought a bunch of parts actually for the very thing that we're talking about. I'm getting the bug to build a shaft and rotating system with, and so on. I just like the way of doing that with where it's removed from the actual motor, so you don't have the interference of the motor with the system. Like for example, this is used in those little cars. This is a couple of bearings. See there, a couple of more bearings there.
Yeah, yeah.
And of course, the challenge is to find all the right shafts and so on, right? So one of the things I've done recently is I got these shafts from the hobby shop.
Yeah, yeah.
These
These
are carbon fiber,
cool.
very expensive carbon fiber hollow shafts. So the idea here is you can put a bearing around it, and if you got say a ball like this at the end of your shaft, maybe something like that, then you can actually have bearings on it and still access the filling hole for this through the actual shaft. Or you can put one shaft inside the other.
Oh, that's looking good. Yeah. Wow.
So you can rotate. There it is. You can rotate one inside the other one. You have another set of. There you can see it there. You can have another set of bearings here, so this shaft rotates independently of this one, so you can rotate both of them at the same time or opposite to each other and so on. So it gives you, in fact, there's 1, 2, and then I can put the third one in as well. I think I got it to fit. Oops, it didn't fit that way. I have to. Yeah, that'll fit in there. I just have to get the tape off and so on. So similar to, for example, we have experimented a bit, and it's a good option. Those little remote-controlled helicopters. They have them now. You can buy them fairly cheap, where it's got a twin rotor. So you have twin counter-rotating blades on this helicopter, and there's no back rotor. It's just two twin rotating things.
Yeah,
And
I've got
oh, actually, they still have a back rotor too. And that center post is hollow and has a shaft going up through it, and a gear system underneath, so you can independently rotate each of those counter-rotating blades. So there's a great possibility to hook up a Gans ball or a reactor ball within another reactor ball. Essentially, you can control each of them independently with the remote control for the helicopter.
Yeah, no, that sounds good. Definitely worth playing with, yeah.
Yeah, we were going to rig that up. Guy had picked up one from the thrift store that was in need of, and we tore it all down and so on, and he's using some of the parts for that. But you can get little tiny wee ones now that have the twin blades and remote control and all that for about $30. In fact, you can get them with a video camera now for about $30. And they'll land in the palm of your hand and fly around the room and stuff. They're actually great fun. I've got a couple of them somewhere, but I don't use them anymore.
I've got two of those I've been playing with for a while, yeah.
Yeah, so you could have something like this where you have your individual little Gans balls about this size, and those things are whipping at a very good RPM. They're probably doing 7,000-8,000 RPM or something. Full tilt, maybe even more. They're quite amazing for the size of the motor.
If you keep it small, you're going to overcome a lot of problems.
Absolutely, and Keshe's always said that in effect size doesn't matter when it comes to that a tiny wee reactor could have enormous power. So maybe something this big would be enough to be a good demonstration. But what is the need for the high RPM? That is a bit of the question. What is the thinking on it? Like for, as was mentioned before, we were talking about low RPMs for quite a long time with Keshe technology not spinning over 1,200 RPM, say, or even a couple thousand maybe. And all of a sudden it's 8,000-10,000 RPM. Pardon me, sorry?
I was just saying that I remember Mr. Keshe talking about how he would spend weeks getting the field developed, getting the field to expand at lower RPMs, around, I think he was saying like 3, 4, 5, 6, something like that. And I thought that at the higher RPMs that he found it was easier to develop, those fields expanded much quicker.
Yeah, when we were doing our reactor thing with, actually with this guy here in the background, you can see that very well, but with the 3 reactor balls and so on, the idea was to keep, still it wasn't over 2,000 RPM, because he was saying that they tried it at high RPMs and it didn't work in that particular format. So
okay, yeah.
But then, it's dependent. That was for a different setup. That was with the Gans rings. That was the famous Gans rings, actually. That we're starting to work with Gans in the balls, which would form this ring around the,
around the central, a band. Yeah,
a band, that's right. Band's a better word for it. And you'd have different colored bands according to the density of the Gans when it rotates.
How about the word donut?
Well, yeah, but all you can see on the ball would be the band itself. You don't, it's not really a donut inside. It's like a series of cylinders, more or less. because they're layered on density, and this part of the curve here, as it rotates like this part here would have the most, the heaviest Gans would be here, and then the next lightest would appear at a band here and underneath, and then the next lightest a band over that and under this one, because they layer inside that way. And,
But it's hollow in the middle, right?
it's hollow in the middle and almost straight down in both sides. It doesn't like curve up and around with the Gans the way you'd think. It's more like almost, it forms like a cylinder inside. But there's also sometimes there's flows that happen as well. In fact, I was reading an article about, they did a scientific report on one ball inside another ball and with liquids in it, such as water, a non-compressible liquid, and rotating these balls at different speeds. And one was both balls going in the same direction at the same time, and the other was the outer ball rotating in one direction and the inner ball a different direction. And it sets up these resonating structures, vortex structures inside. And at certain RPMs, then they're a regular vortex in a certain formation. And other RPM right next to it, suddenly it'll all disappear and it'll be uncontrollable, or what do they call it? Instead of a regular vortex, it'll be
chaos.
Yeah, disrupted.
Well,
disrupted.
it might be a vortex here and then flip down there, flip back, flip flap. It'll start resonating or flipping and so on. So anyways, it's interesting that these different, again, I'm thinking with, if you have a ball like that inside the other one, according to this scientific report where they analyzed it all, it sets up these field structures where you have energy and not energy, essentially, that are demonstrated in the actual water structures. So you have a little whirly vortex here, but no little whirly vortex beside it, and then a little whirly vortex, and it could be a stable, that's the word, a stable structure or an unstable structure, either a stable vortex or an unstable vortex or vortex structure. So an unstable one might be flipping back and forth, or it might form and then dissipate and form and dissipate and so on. A stable structure will be one shape that'll form at a particular RPM with these things. So that's happening even with one ball. There's different flows and things that are happening inside. It's not stagnant by any means when it gets rotating. And then and if we start mentioning other things that happen when it's rotating, such as gravitational effects, then that gets into a whole other discussion too. So, or the magnetic effects and how Keshe got, the famous 129 Tesla from rotating some copper balls, basically, that Armin had made. Hard to believe, but on the other hand, it's entirely believable. And
what does that mean by being used, a Tesla coil being used and not?
No, not a Tesla coil, no. Tesla is the word that they have for magnetic fields. They name magnetic fields after Nikola Tesla. So like a 1 Tesla magnetic field is quite strong, and usually it's measured in millitesla or Gauss and milligauss and so on. But to get say a 10 Tesla magnetic field is almost unheard of in the laboratory, and they have gotten up to, I think, 100 Tesla or something like that. They've gotten even more than that, but only in a very specific, where they've used actually as much energy as an entire city for a microsecond in order to create the fields. But Keshe did it on, what did he say, 20 watts of power or something. 10 or 20 watts of powering these little motors like we were talking about.
Yeah.
So what were we talking? We were talking about getting up to 10,000 RPM and some of the ins and outs of that. And one thing about it is you got to be careful with something like this rotating at 10,000 RPM. I've done it. I've rotated ping pong ball at 10,000 RPM. I've had it light up as a plasma ball while rotating it at that speed, and so on. There's lots of stuff you can do with it, but to do it continuously, that's where it's easy to take your little contraption and spin it up for a few seconds or maybe even a minute or so. But to keep it spinning, that's where it gets dicey, because
it's one thing I've noticed that anyone who's worked with these for a while is very hesitant to spin it up fast, for an amount of time. So I can imagine the destruction of balls left, right, and center, trying to get it exactly right.
Yeah, that's the thing. And what can happen is, especially with those, this isn't the best example. I have some other ones somewhere, but the famous globes that people are using, balls within balls and so on, spinning them up, and suddenly they shatter. Well, yes, they do, because they're almost all acrylic, and acrylic is known for being tough. It's tougher than glass, basically, of the same thing, but it's also
brittle. Yeah.
When it does break, it shatters. It's brittle, and it would explode, literally. Whereas if it was polycarbonate, then it'd be about roughly 20 times stronger, and it would tend not to shatter. It would tend to blow out or bulge or something like that, rather than shattering. So I saw in the chat by Mr. Sun Kim. He had something in the chat earlier about, to me personally, about they now have 3D printing in polycarbonate. I'm thinking, wow, that's interesting, because they couldn't do that before. So now if you can do polycarbonate in your 3D printer, you could actually print out what you'd like in the way of a sphere and have it be strong and be able to take the RPMs. And then you could print it with its own particular fitting that would fit onto your motor, which is the biggest problem, is this fitting. How do you get it to mate to the motor? It's I spent probably in the hundreds, if not thousands, of hours thinking about that. How do you take a ping pong ball and match it onto a motor shaft and so on? And there's millions of ways of doing it, that's for sure. But what is the most efficient, easiest, most elegant way of doing it, and safest too at the same time, so it doesn't come flying off at the worst possible time and so on? So
just not using ping pong balls at all.
Well, ping pong balls are pretty tough, actually, when you think about it. They get whacked at very hard, hits, and a quality ping pong ball is pretty strong. But and I've proven that a ping pong ball can take a full vacuum as well.
Yeah, well, giving the hit a random hit would affect on one point, but when you're rotating it, I bought a couple of different ping pong balls from different places. One expanded, and it turned into sort of ellipse shape. I thought it was an anomaly, but it wasn't really. It's just like ping pong ball being silly. And
Yeah, that's true. They're made to take pressure. They're made to have pressure inside that maintains the form and so on. They're not made for putting liquids in and rotating at high speeds. But yeah, so polycarbonate would be a better choice. If we had some polycarbonate balls available, if somebody was going to print out thousands of them, they could probably sell them to people that are experimenting in this kind of thing. One thing I've done is I always try to put a protective shield around my rotating gear if it's going to be dangerous. Otherwise, if it does explode, always get it on video because it makes a great YouTube video when things like that happen. But no, seriously, this is what I've put around this. I've got a rotating, the center reactor here that you can see sort of in the middle here. Oh no,
I just noticed something. You're not in your usual setup place where you usual at. I don't know. You're somewhere else. Like you're surrounded with a lot more.
No, this is my usual stuff. I'm just I'm reorganizing a bit as I go along.
Okay. Oh, of course.
Let me see if I can.
Looks wonderful. It looks really wonderful.
Okay, so anyway, what I was trying to get to is this thing here. So I've got a rotating sphere in the middle. It's hooked up to these things, so everything rotates together. It's hooked into a sewing machine motor here, which is a great motor to use for this kind of thing, by the way. You can put on different pulleys. If you put a big pulley on your sewing machine motor and a small pulley on your rotating assembly, then you can get it whipping up to pretty high speeds very easily. The variable foot control with your sewing machine, and bingo, you're ready to go. Plug and play, as they say.
You set it up sideways.
Well, okay, you want to see it the other way?
Oh, so good. Oh, okay.
Yeah, this is set up so I
put
can
my duct tape back on.
I can go upside down this way, or this is actually right side up this way.
Ah, oh, good.
So yeah, I've got it on a pin.
Yeah. Cool.
I've got a pin so I can rotate it, and then of course I could also tilt it if I wanted to orientate it with the Earth's magnetic field or something like that. But what I wanted to show is I've just got this simple cup here, which is actually a polycarbonate cup. I was going to mount it in place. I just stuck it there to see. But it's protecting this center sphere, which is glass. It's a lab flask, and it's pretty tough stuff. But if it ever came apart at speed, it wouldn't be a pretty picture for those around. Ping pong ball coming apart is one thing, but a glass globe is pretty iffy.
Pretty bad.
I've had it rotating up to probably 8,000 RPM, or I think it's been up to 10, but I wouldn't recommend it for anybody, and I only did it for a brief period with a very good protective covering. But this...
Rick,
go ahead.
Rick, have you ever considered putting a lead shield around your motors? You were talking about the fields put off by the motors.
Let me grab my lead shield now that you mentioned it. What do I do with the lead shield? Oh, there's the lead shield.
You can usually get that stuff. They use a lead shield.
I can't hear you until I have my headphones on here. Say that again.
They use lead shields or pieces of lead like that when they build a shower. They use it in the bottom of the shower before they put the tile on it.
This is actually sheet lead. It says so right on it. $5. I picked it up recently at the recycling shop, and it's quite easy to bend. It's quite thick, but easy to bend like lead. I'm not worried about handling it because it's in this form it's not particularly toxic. It's when it gets into water that it, or into the ionic form, that it can do real damage. But you're talking about put that
lead around the
I hadn't
reactor
thought
that-
of lead, but that's not a bad idea. Like it could be around the motor,
Mm-hmm.
right, to protect against the fields that come off the motor.
Oh yeah.
Or if you're getting fields coming around from the reactor you're worried about from some sort of fusion fission
How about
reaction.
rather than not around the motor, just a layer of the the layering of the cores.
Well, like on Lee's setup, he has a whole building, so to speak, with the motors underneath. Lead could be on the very top of that piece of lumber, below the balls and isolate the motors.
Yeah, I'm not sure if lead is the best. What are you isolating against? Would be the question. Is it magnetic fields, electric fields, electromagnetic fields, plasma fields?
Yes, all of the above that the motor puts out.
Above. Yeah, it definitely puts out a broad spectrum because of the sparks that come off the commutator, especially. Sparks tend to be really broad spectrum and affects all of the electromagnetic spectrum, from light right through to sound, right through to all the frequencies of radio frequency. So, yeah, they're a bugger to isolate the motors. The brushless motors are a little more quiet, but the brush ones are especially noisy. So go ahead.
I was wondering, in terms of constructing it, it looks like a very elaborate. It looks like it's just like amazing amount of work put into that. And
It was to. I'll tell you quickly that it looks like a lot of work, and it was a lot of work to get to this point. But I tried to use all standard fittings that could be. My original idea was to use skateboard bearings. Shafts available from lamps, like the threaded shaft from lamps and that kind of thing.
Awesome.
Which fit onto brass fittings. So in this case, for example, through the brass fittings and the hollow shaft, I can access all of these ping pong balls, the inside of them, through a needle that goes in through the top here.
Yeah.
And so I could put different things on the fly.
Yeah.
And still have it sealed through a seal inside of here and so on. And all of these are available, like these are Home Depot, Princess Auto, Canadian Tire, all these kind of places that have standard things. And I was trying to incorporate the skateboard bearings into it as well, and they kind of work, but it was hard to mix and match everything, I'll tell you. Yeah. So it became too much of a pain, and I was heading to bicycle shops and trying to explain I wanted a hollow shaft that fit these bearings, and they could sort of give me one, but it didn't correctly work, and it was a
I can't believe you got bicycle shops down there. It's really nice to have one. I know the feeling. When I was a child, I had bicycle shops around my what you call town, and it's just like
there's quite a few of them here, and they have all the bearings and parts and so on. So the other thing is I wanted to use the sewing machine motor because it's commonly available on all these old sewing machines. You can buy the whole sewing machine quite readily. And it's got a variable foot control, so you can control the speed, or you can hook it up to a variac and control the speed that way. But the feature of this is the drive system. Once the bearings are in place, just pushed into these wooden holes, and it's not that much in materials and so on here. The drive system is just one rubber belt drives the whole thing. It's an O-ring.
Oh, I see.
All of these things are connected together with one rubber belt that I can pull off like that. I don't know if I can remember how to put it back on again.
So good.
Let me see if it's this way. That'll work. Yeah, so and the way it's working now with these rubber belts is the three reactors, there's one in the back, the 3 ping pong ball reactors all go in the same direction, and the sphere in the middle
Which
goes
is
in the opposite
counterclockwise
direction.
or clockwise.
Whichever way you
We
hook up
decide,
the
yes, of course.
the motor and so on. But yeah, and the one in the middle goes in the opposite in this case, and I can hook it up differently by just making a switch in the belt here and have it turn in the same direction as the other ones, and so on. It's easily configured is the idea, and it's can be relatively safe with I've actually got a complete shield, a polycarbonate shield that goes around the whole thing. It's not right
Very
here.
easy. And whenever I look at your videos and stuff, I'm mesmerized by them, and then I think about how to construct them, and it's just like availability to be able to construct them is not so easy. It's just like
It's
challenging,
true,
but it's so inspiring, amazing.
Yeah, we should really have kits with some of the. That was my intention, was to be able to have kits that people could buy some of the materials locally, and if they need to order the kit, they could order the whole thing and so on. But there's, I don't know, there's a lot of liability involved, and you have to be careful what you're giving out these days, because it's a dangerous situation when you get things rotating at more than 1,000 or 2,000 RPM, then it starts to get dangerous. There's no doubt about it. That's how I originally got my my online reputation. Actually,
So true, sir.
I got called.
I'm very
I
sorry
got
about
called.
that because it's so joy.
I
hear
got
it.
called crazy Mr. Fix-It Rick by this guy in a gadget magazine, online magazine. I kind of took offense to it, but I was asking for it because I was rotating a skill saw blade magnetically attached to a Tesla turbine that was hooked up to my air compressor running at full tilt, and this thing just took off, and it worked way better than I thought it would. And the blades going around on just held together with magnets. This is like my first viral video basically, and it was just insane. It was crazy, and I was lucky to live through it. And I was foolish, but they called me crazy Mr. Fix-It Rick, and it started some viral videos, and I started doing other ones, and it picked up, and my YouTube channel became very popular for a period of time from all that craziness. But it wasn't crazy in a way, because I had very solid experiments and scientific stuff that were underlying the craziness, you know. So that was the fun part of it. But anyway, the idea is that you got to play safe, and polycarbonate protection is important. I've made up several different polycarbonate containers for the different spinning stuff that I've done. I've spun CD turbines at 15,000 RPM and with magnets on them. If they come apart, they come apart big time. They're like powerful units, putting out a horsepower or so of power, and but I've always had protective cover around, other than that first experiment that I was just talking about, which was totally crazy. I'm lucky to still have feet and so on. But so suffice to say, find something polycarbonate. There's glasses, for example, you can buy that are polycarbonate. Don't get the acrylic ones, because there won't be any protection if anything comes apart. And a glass like that would fit around a ping pong ball very easily if it's doing 10,000 RPM, which it can. Some that can handle that. A quality ping pong ball that's balanced. The balancing is important. I'm sure we talked about earlier. If it's out of balance a little bit, has a little bit of wobble, then it'll start just ripping the whole thing apart. I wanted to mention that's the thing about these acrylic balls. Everything's fine. It's going, 5,000, 6,000, 8,000. Maybe it even makes it to 10,000 RPM. One this size one's too big probably. But maybe a smaller one that size would, and you think, wow, that's great, made it to 10,000. It might make it to 10,000 the first time, maybe the second, maybe even the third time. But eventually, at some point, it's going to fatigue crack all around where it's mounted from just a little bit of vibration, and just because it's not made to take that kind of stress. And it'll have little hairline cracks you won't even notice, and then at the fourth time, all of a sudden, boom, it just totally explodes. And one has to be careful because acrylic splinters don't show up on x-rays. Think about it.
Yeah, if you're gonna go high speeds, keep it small. Don't try to spin a 4-inch ball at 10,000 RPM. It isn't gonna work.
Yeah, because it goes with the radius squared. The pressures on the wall here and so on increase exponentially as you increase the RPM and increase the radius. So keep that in
Definitely
mind.
remember to pull out my Ned Kelly suit. Yeah.
Yeah, you could have, maybe it's time to put on the hockey uniform with the full face shield or something like that. Who knows? There's different ways it could be done. Cleve mentions ceramic bearings or high speed. Yes, I've tried a couple of ceramic skateboard type bearings, and they work quite well. And also the thing about ceramic is you keep less metal away from your reactor core that's spinning around as well, which is probably a good idea. I think full ceramic is the way to go. Unfortunately, they can be $80 a bearing, something like that. And it's pretty out of range for 2, 4, 6, 8. Yeah, $500 or $600 in bearings there, and they can still go too when they get out of balance and they get pounded too hard with dirt and that kind of thing. Yeah.
Thank you for all
Yeah,
that.
thanks for that. That was
you
a
so
really
much.
good overview.
So Mary says, Rick, has anyone tried injecting Gans into raw eggs inside magrav coils?
Wow. Never heard of that. Wow, what a creative idea.
Gans into raw eggs inside magrav coils. What would that do? She's curious. Anybody have any ideas? Any projections on what might occur in that situation?
So what are we exactly doing here? Like injecting Gans into an egg and then placing the egg on top of a magrav unit? Is that what we do?
Yeah, it'd be essentially like this guy here. And if this was, say, an egg, and a raw egg, and we inject it with some Gans, put it on there, and wait.
I reckon that's a great idea. It's definitely nano-coated.
Oh my goodness, so good.
It's almost like it should hatch into something, eh?
Yeah, it's pretty organic. That's a great idea.
Amazing idea.
Maybe.
Now, part of what I was thinking about earlier today, and I think this is an interesting idea, what if we took that egg or ping pong ball with Gans, either which way, and what if we put it in the center of this coil arrangement, and then what if we pulse the coil, like I have it as a sensor here, trying to sense the Gans in the ball, but what if it was pulsed with the fields from the coil, and then more or less we'd still listen to it, but we'd listen to the more or less the echo of the pulse. So it would be pulse, echo, pulse, echo. What does this ball, how does it respond to that pulse is the idea. And of course we have Gans balls in the coils, in the magrav units, three coils, usually 3 levels.
Yeah.
what is actually, maybe with this kind of setup, we'll be able to, like, the coils are being pulsed in the magrav units from the 60 cycle hertz, 60 hertz, pulsation that goes on. Plus, we're told about it takes a pulse, it takes a heartbeat to start the magrav, to start the unit. That's why we have the two refrigerators hooked up in the infinity loop, is to create that pulse for the unit. So I know I can create a pulse through my software when I hook up the phase difference with the pitch in just a certain way. I can set up a pulsing, what do you call it, a standing wave kind of pulse that comes through, a particular low frequency pulse. And I think that pulsing this coil might be interesting to find maybe the resonating frequency, or the what does the coil like? What is it like the most, I guess?
What's in the ball? What GANs in the ball?
In this one?
Sorry, I missed that one. Yes, please.
This one is CO2 GANs. I put CO2 in that one and this one actually, but ideally, no, this one, this other one here was the CH3, actually, the pink one.
Okay, the pink one is the CH3, and the
that's
the
the way
yellow
I had it
one
set up.
is
The yellow one
CO2, and the white one is the CO2, I guess.
And that was actually the copper oxide, that one.
Oh, okay.
So, this ideally would be zinc oxide, actually, I think, because that would be nice for that one. But in any case, it's just the CO2 Gans water. Got this little unit that... Pardon me?
I was just saying I had another thought about the egg. Maybe it's not such a good idea for flight systems because you would have the amino acids of the chicken, and you might have to carry the chicken into your spacecraft to control it.
Well,
you have to talk to the chicken.
Maybe putting chicken DNA in would help it to fly. Maybe we should have something more like eagle.
Yeah. Hey. Yeah. Maybe.
Let's see if that fits in there.
Oh, that is really good. I'm afraid I have to say this. It's just such a brilliant idea. It's so good.
Will it hatch? So yeah, I think there's something to this this concept that we can sort of combine the two technologies, the old school and new school stuff, without having to go with a lot of elaborate circuitry and whatnot. We just go with very simple. Crystal radio is the very simplest of all circuits. In fact, it may not even need most of this stuff. It may only require just the diode, or maybe not even have anything and just hook it directly up to the computer with nothing in between, essentially. And I haven't even tried that part yet. And maybe that's the most efficient way to do it, from plasma directly to computer. Plasma computer interface. Well, there's a lot to be experimented with there, that's for sure.
There has to be experimented, and it's so exciting what you're doing. Thank you for so much for doing it. It's just unbelievable.
I wish I could do it full time, basically, but so many other things going on, and it's hard to control these projects because one thing leads to another, and you want to try this and that, and all of a sudden your whole desk is full of stuff that you want to try, but there's so many things to try that you forgot about the first idea and follow through that properly. So
It's hard to find room amongst all the other experiments from previous years. That's what I find.
yeah, it's true. So anyways, we're getting on in time here. Is there anybody else who wanted to show or tell or ask or anything else here today?
I mean, in terms of setup, I have, I think is a precious is that I've added 3 drops of CO2 into really tiny pots of plants. Agricultural side of it, it's really interesting, and I'm trying to do as much as I can because it really does. I don't know whoever have you if you've ever tried it, if you ever experimented it in your backyard or in anything within your house, little pots that you have. If you made any CO2, the bit that accumulates on top of the actual Gans, you're gonna get it drops of it and put it into the water that you think it's as pure as possible, and you're gonna put it into your beautiful plants and flowers, and you're going to see honestly at your home. It's not like a industrial scale. It's nothing like that.
Yeah, I
In
think so. People are giving good testimonials about that.
just the first 3 days, I've noticed it really does tax the beauty of the CO2, the field of it. It inflicts it into itself. In 3 days, it expands drastically, unbelievably, and I have noticed that. Just do it with your seeds. Put your seeds, practical purposes. Put your seeds in between some napkins and drops a couple of drops of CO2, and then wait as much as you want. That doesn't matter. And then plant it and then see the benefit of it. Try to understand the beauty of the agricultural side of it. It's just really easy. It's so beautiful.
Right on. Good point.
I pushed it a little bit, but it's all right. You understand? I love it. I don't know how to put it right, so I want to put it right. But yes, please try it. It really does work amazingly.
Okay, I think I'm going to wrap things up here for today. It's been good. Thank you for putting up with my strange sounds and wacky workshop here. And we'll continue with more next week, probably. Hopefully get this little system more refined here, and I've got a lot of variables and loose ends that need to be put together. But I think I'm on the trail of something that's worth pursuing. So I'm going to carry on as if, and hopefully we'll be able to measure these little vials of CO2 Gans, for example, and I'd like to be able to just stick it inside my coil setup and be able to get a reading off it that'll show up on the spectrograph and show up on our audio as a distinct frequency or distinct signature, let's say, an audio signature, not maybe one frequency, but a combination of harmonics that it's You know, I wanna hear what Gans should sound like rather, and what does distilled water sound like? What does salt water sound like? What does salt water from different oceans sound like? That would be something to be able to actually hear the difference in the salt water from different oceans. Can we hear bacteria and viruses in our waters? Can we hear the crystal structure? Can we hear how happy the water is? How about that? Happy water. Can we hear how much it's suffering? Maybe we don't want to hear. Maybe that's why it's never been done before.
Oh, it's never been done before. Yes, also true.
Maybe water's becoming conscious and wants to be heard. So these are the big questions that'll be pursued. Stay tuned next week for more. Okay, I'm going to end the live stream here because I'm starting to get giddy, number one, and it's been over almost about 4 hours, which is pretty much our outer limits here. Thanks everybody for participating as usual. And for those who didn't participate, why not? Put something together. Put something wacky together that only you can do. You know? And be like me. Just do something crazy. Like decide the world needs something to shake it up a bit, and you have to do something crazy. And if not you, who? And if not now, when?
I have to do a testimonial right now. And well, years ago, a couple of years ago, maybe more than a couple of years ago, I came across with Mr. Rick's video, and I was just interested in Tesla, and it was one of the major videos that has been shared, and just like shared and shared and shared. Crazy. I loved it. It inspired me. I had no idea if Mr. Rick Crammond was related to any way, any shape of Keshe Foundation. And it's just unbelievable. And
yeah, that stuff all led directly to Keshe in one way or another. I was seeking.
I've gotten excited here. I'm sorry. It's really important to put it in the right way because the inspiration is so intense coming from you, and it really is bringing up to a point where I was nothing, and I was watching your videos on YouTube, and I've suddenly inspired by it, and then I came across with Mr. Keshe and Mr. Keshe's blueprint, and I had to make sort of connection in between you and Mr. Keshe, and then I had to do my own things. It was so inspirational. I mean, I didn't really follow the whole blueprint and everything, but the inspiration, and it's just like so good. I don't know how to put it. I could never put it in anywhere in a place.
Well, that's right. You don't have to understand everything in terms of the blueprint or in terms of any of this technology when it comes right down to it. But being inspired, it really helps a lot because then,
So true.
I mean, that's what we're here for more than anything else in a way. It's more important to get inspired than to have all the detailed knowledge. Because the inspiration allows you to be more inquisitive and follow through on your own and try this, try that. Why not this? Why not that? And that's the main phrase I've learned from Mr. Keshe from day one is, why not? Can we try this and that? Can we do this? Can we alter that? Can we change this? And he goes, well,
Okay,
why not?
I'm sorry.
No, go ahead. I was ranting. Go ahead. Alper.
Well, the only thing that I can say that I've learned from you that is um, be fearless and do what you could do within your environment, within your materials. I learned how to recycle from you. That's all I can say. I've learned how to use my environment to my advantage. That's why I learned from you. And um, there are many aspects, many details that resembles my personality which I can't really explain it here. But so much inspiration has involved in it, coming from you, sir, and I can't really put it into words. I want to say is thank you dearly. Thank you so much. I bless you. Thank you so much, all the participants, and it gives my eyes a tears. But it's so true. It's all in my heart, in my soul, and
Yep, that's what makes us a little
speechless.
different than your ordinary science shows and so on. We do have a heart here somewhere in the middle of it all, so to speak. And yeah, well, thank you for that, Alper, and thank you for your inspiration as well. You've been inspiring many times here, and it's all part of the same game. So, okay, I'm going to have to end things here, but thanks for ending it on a good note, and I appreciate your input. I'm thankful, full of gratitude, actually, and I've had an amazing time from the workshop here that occurred with all the ladies that put it together and the participants that showed up and so on. What an incredible crowd. And I walked into a room of about 20 people with not one of them did I know personally before I entered the room, and yet they all seemed familiar to me after just being in there for a short period of time, and they just seemed like family. So it was quite an amazing experience in a way, and of course they all sort of knew me without me knowing them. In some cases they'd been following the various either my stuff or Keshe's stuff for the last couple of years, and I didn't even know of them, and they were local, and they were so thankful and so full of gratitude for the stuff that I did and so on. I didn't even know who they were until now. And that was quite an amazing experience when that comes out and people show their appreciation for the hours and hours and days and years of hard work that goes in.
Years and years and years, not days.
Of dedication and loss of other things in life and so on. No, I'm not complaining. It's been the greatest experience I could possibly imagine on this planet. That my life now is, I can't imagine doing anything better. I've got the things I want to do, I'm doing, and where I want to do it, and so on. And even more so as I go along, I'm realizing it and appreciating it, and so on. So it's really cool. Life is good in many ways, in spite of breaking my knee recently.
Sir. Thank you so much.
Okay.
Thank you so much.
Enough of appreciation time here. Let's get out of the workshop. Okay, thanks everybody. I'm going to stop the live stream now. And